start it now. Sorry.
All right, cool. No worries. Right,
Take it from the top.
So once more from the top with feeling. Right. So.
Okay, we're good.
Right. Burning question for me in my head. We've been told that the level line is not the same as the horizontal. That there is a deviation of the level line from an established horizontal plane. And over a distance that this deviation is measurable. It's never been measured. I've been asking for 2 years for a method to be able to measure the curvature, the claimed curvature of the surface of the Earth from standing on the outside of a ball. And nobody has been able to give me a direct method measurement. They can do it through observations and calculations of refracted objects over a distance. Now, to me, this isn't a direct measurement. So I am asking the question, how do we measure the curve of the level line? Because if it's there, it's a physical thing. The water is said, or the surface of water is said to be that level line. And that level line curves, apparently. I had Armour, well, I actually asked somebody else to do this for me, but they didn't come through. So I had a chat with Armour this morning about doing a graphic for me. I asked him to model in a 3D program. Has my screen share changed, Joe?
No, it hasn't changed for me. Oh,
yeah, well, you could see it moving. Yep.
Right, so you're looking at that 3D model that Armour did for me this morning?
Yep, looks like it.
Right, okay. It's a red rectangle with another grey rectangle running through it. This is the model that Armour did for me this morning. He actually did 1/2, so this is what Armour did for me this morning. What he did for me was actually upside down, and he had the curve running kind of upwards and the horizontal plane along the bottom. So what I've had to do is flip it and rotate it. So now we are looking at, if you can see the grey line. Can you see my cursor as well? Are you able to see my cursor on the screen?
yeah, we got the cursor.
Right, okay. You see this line here? This is representative of the horizontal plane projected.
Actually, I lied, DP. I don't see your cursor. That was my cursor.
Okay, right. Well, this is going to be a bit difficult to describe then. You see there is a red rectangle. At this end, the closest end to us, there is a black perpendicular line to that red rectangle. The surface of the curve is in the red plane. Now, the point just above that, the grey line just above that runs parallel with the plane and intersects the curve in the center point, is the horizontal. Now, this model, like I say, it was half. What I got was half. I only asked for half. I asked him to model it over 1 mile. So we have the black line on the right hand side and the red plane. So the black line comes out of the red plane, the curve comes up into the center, and then the horizontal is then established on that black line and intersects halfway through the model. Now, I've just moved part of that by accident, so I'm going to have to pop that back. So sorry about that. Let's have a look. There we go.
I don't see your cursor. I just wanted to say that. I don't see your cursor.
Yeah. I don't think anybody's seeing my cursor at the minute, Beer Man. Sorry about that.
No
but
worries.
I hope you can follow along with what I'm describing.
But when you highlight something, we see the highlighting.
Who was that? Was that Jesse?
Yes.
Yeah, you were really quiet for me, Jesse.
That's because my microphone was stuck up. So when you highlight something, we do see the highlighting or the selection.
All right, okay, that's good then. That's good. Right. Well, I've just moved this bit on the left-hand side. It was all lined up. I just moved it by accident, so bear with me a tick and I'll try and put that back. There we go. That should be it. Right, so what we've got is we've got this one, which is 1 mile. And as you can see, we have the horizontal plane established, and then the model underneath, which is representative of the Earth's surface, given the radius of the Earth's surface in the model that I asked for. And what I've done is I've flipped that and then rotated it and then put it back to back virtually. So now we have a 2 mile section of what is supposed to be the Earth's surface with a horizontal plane of intersection. Now, the measurement I'm asking for is this one at either end. You can take either end of this and you should be able to measure the drop from the horizontal plane, from an established horizontal plane of that surface. Now, that surface that I'm relating to is water. According to the ball model, water adheres to the surface of the Earth, i.e. we live on a big ball of water. Now, if that is true, we establish a horizontal plane and then take a direct measurement of the surface of the water from that horizontal plane. How do you do that? We ask ourselves, because this presentation isn't so much about me putting a solution to this out there, although I will offer a solution to this. It's more about us all coming together and figuring out that there is a place we can do this and there is a way we can do this, and we all know that there are tools available to us to be able to do this. A direct measurement of the surface of the water deviation from a horizontal plane. That's all I'm asking. Now let's have a look. Which one? I'm just looking for a new
Is this
screen
true?
share.
It's the is it the equinox today?
21st,
Yep.
don't it? Yeah, could well be then. Right. Right, are we on the same screen? You should be seeing Angkor Wat in Cambodia. Is my screen share changed, Joe?
Yep. Yeah, we see it. Looks good.
Right. You see me zoom in and out, yeah?
Yep.
Right.
Mhm.
Okay. This is a very special place in Cambodia. It's a place called Angkor Wat. It was the seat of the Angkorian Empire, which came to an abrupt end roughly about 1,000 years ago. It is a massive temple complex. It's in a really bad state of disrepair, and the World's Heritage, is it the World Heritage Fund, I believe, are working through it methodically, trying to repair some of the temples. Now this is a very special place because if you look here, I'm just going to change that to miles. Is the distances coming up on the screen? Yeah, I've just put a distance marker in there. Does that come up on the screen share?
Yes.
Right. So that has come up. I'll do that again because it's it came up in meters and I want miles. Right. So that is 0.8 of a mile. That stretch of water there. And this one here. Oops. Got a new. This one here is just under the mile. So in this stretch of water, there should be curvature pretty much bang on to the model that Armour did for me before I mirrored it and flipped it. So one side of that model should adhere to this stretch of water. Now the question is, how do we measure that? Is there a way of measuring that curvature, that suspected curvature, apparent curvature? Is there curvature? I don't know. I don't think there is. I think that the surface of water forms a horizontal plane. So to test it, how would we do it? Any suggestions, anybody?
My first question is, why aren't we looking at a bigger sample size of water, like the Nile or the Amazon?
This is the area I have chosen to focus on for this demonstration. Once I've been through this demonstration, then you'll be able to take what I go through here and apply it to any body of water. And because what I'm looking at is the relation between hydrostatics and the water surface and the geometry of the plane, and trying to tie the geometry to the water surface and being able to measure a deviation or not of the water surface from that horizontal plane.
So you've got the elevation markers that we can use then.
Why do you feel you need elevation markers?
To see if there's a notable undulation in where the water's edge would be touching its container at the beginning and supposed end, let's say.
Right.
Then we'd be able to see if there's a negative or a positive drop, or even if there is an observable drop.
Well, the way I kind of figured doing it, right, is there's a couple of different methods that are out there. I'm going to swap screens again, Gio. Sorry to do this to you. Where are we? I'm going to go to a drawing package. And I only have the stop streaming. Right, so I'm going to have to start again. Sorry. What am I looking for? I'm looking for...
That's it for this time, folks.
Oh, I know, guys. Sorry.
Yeah, if you're going to share it by individual windows, then yeah, we'll probably have to, everyone will have to rejoin every time. Whereas if you do it by like a whole screen, you know, like you can share by the screen, then you could bring windows in and out. But
right. This is... Oh, right. I see. So if I share that screen, this is the first time I've really done this, Gio. So you'll have to bear with me. I am learning.
It restarted for me.
There's popcorn in the lobby.
Yeah, please feel free to grab some. So you should be able to see that Blender model again now. Right, so if I share that screen and then I can just transfer... Right, oh, blimey. Right, if I transfer that to there, you should be able to see Anchor Watt again now, yeah?
yep, yeah, that works.
Right, you got that, and I'm just grabbing my drawing equipment. So you should be able to see my cursor.
Yes.
Yeah, and a red line.
Mm-hmm.
Yeah, right, okay, cool. Right, Ruhif as an example, right? I'm just using Ruhif as an example here. He would like to set a little man here with a measuring rod like this, and then all the way down here Ruhif would like to be with his equipment, looking at his little man all the way down there, a mile away. And Ruhif wants to make some kind of angular measurement here and figure out some kind of curvature rate. Like this. Not very straight lines, I do apologise, but I'm sure you get the gist.
You said curve. No.
Sorry?
You said curve. Your lines were curved.
Yeah. Another way of doing it would be like Bev could set up his water levels all the way along here. So he's got his water levels like this all the way along here, and then you measure the level of the water down to the level of the water, level of the water down to the level of the water, level of the water down to the level of the water, level, 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 level. So you could do it that way. You could do it with an auto level. Now I thought of like an auto level taking shots across here like this, shots backwards and forwards across there like that, but unfortunately this distance here is 200 meters. So as we all know, this is a little bit far for an auto level. Let's just get rid of all this rubbish, shall we? So again, if this here if this stretch here can be measured, sorry, excuse me, this like I say, first time at doing this. If this stretch here can be measured with surveying equipment, I mean, Jesse, you're one with the theodolite. What's the optical range of a theodolite? The working optical range. What to keep it within the manufacturer's guidelines?
You know, the manual simply says that it has an accuracy of plus or minus 4 arc seconds. It doesn't say how far, it just says plus or minus 4 arc seconds.
Right, okay, so if you were to measure across here, bearing in mind it's 200 meters, that's all, what sort of accuracy would you get with a theodolite?
Plus or minus 4 arc seconds.
So plus or minus, what does that relate to in feet and inches values?
Okay, let me calculate that. What was the distance?
It's roughly 200 meters. It's just short of 200 meters. It's about 196, I think.
Plus or minus 4 millimeters.
4 mil. So you could get a 4 mil accuracy measuring 200 meters.
Yeah, with mine. Good ones would be 1 mil if they're 1 arc second accuracy.
Right, okay. So if you were to measure from there to here, that's not much further. I'll give you another 50 meters on the length of the triangle side there. So say that's 250 meters. So you got your little man there with his rod, you're here with your measuring machine, and you go across there. Again, would you say that would be within your 400? Sorry, the tolerances you just stated.
That would be almost 5 plus or minus 5 millimeters.
Right. Okay. And then measure again over to here. So you're looking at the same kind of tolerances, yeah?
It goes up linearly with the distance. So if it's the same distance, it would be the same tolerances.
Right. And then you could measure back this way, yeah?
Right, yeah.
Right, and from each of those points you could establish a drop to the water level. Or the level of the water, should I say.
Right.
Yeah?
Well, let's see what that would even be.
No, you could, you know, once you've established your horizontal plane at a height above the land, then all you're doing is measuring the vertical drop to the level of the water. This is possible, no?
Well, the problem is at 250 meters, what we're trying to measure is only 4.9 millimeters.
Yeah.
So that's
Oh.
really not larger than the margin of error. So it would kind of be ambiguous, unless you had a 1 arcsecond device instead of a 4 arcsecond accuracy device.
Right, so the accuracy of the device could improve.
Yeah, some devices are accurate to within plus or minus 1 arcsecond.
Right. Okay. So if you were able to form this plane, this would be a plane, wouldn't it? You are forming a plane with your tool over the water here. And to be able to measure from your established plane down to the surface of the water, this is something surveyors do every day. They establish planes and then measure down or up from that plane. So I don't see how it's suddenly become a problem to be able to do it here over the water. And surveyors do it over greater distances than this with great accuracy. If they weren't accurate doing their jobs, they wouldn't be doing their jobs anymore. So I'm asking for the tools to be used in the same manner, doing the same job, and I'm getting accuracy values that don't quite match the job that the surveyors do. And reasons why we can't measure down from this established plane to the water level. Now, this place is quite unique because if we can establish that this body of water is planar, and we have this body of water here, oh, excuse me, sorry, my Wacom tablet's misbehaving.
Did you want to address any criticism from the YouTube chat? Shout out.
Is there any criticism from the YouTube chat? I'm not even looking at YouTube. I'm not even looking at Discord at the moment. So,
Sean Hawkins says 200 meters not nearly long enough to get a valid measurement.
Right. Okay. Well, you know, keep those arguments in mind, and we'll come back to them. Right. So, the reason why I think this body of water is quite unique is because of this area here, like this. There is one in each corner, like this. Anybody got any ideas why it's unique like this? Because if we can prove that this is a plane, and this is a plane, then this area here is a common planar segment. So if this area here shares this planar segment with this plane, then these two are a common plane. And the same goes for the other end. Up here, if you can demonstrate that this area shares a common plane with this area, then this area and this area is a common plane. They share a common planar segment, therefore it is one plane. And really, with geometry, you only need to work on half of this complex through here, because if it applies to this half, I'm going to do a bit of rubbing out now. It's just full of scribbles. So if we establish that this area here is common in a common plane, so this one and this one are in a common plane. Because this is geometric, you don't really even have to measure the other side. You can just flip it, and geometrically it works. Now you say, yeah, geometrically it works, but what about physics and hydrostatics? Well, in that case, all you need to do is do the same again. Common planar section, and this here is a common planar section. So this is all one plane. If you can establish that this is a plane. So what we need to do is we need to establish that the law of hydrodynamics, or within the law of hydrodynamics, the surface of water doesn't drop away from the horizontal plane. And there is no deviation. Now, you've mentioned, Jesse, that this shot over here, you can't do it with an auto level, no? This is too far. Is Jesse still with us?
Yeah, I'm still here.
Yeah, so this shot across this water is too far, okay? Is there any way that we could like bounce it off this bridge, do you think? Like take a shot from here to the bridge, along the bridge, and then back onto the shore?
So the limitation with the auto level is that you couldn't read the numbers on the rod, but you could still see if something was above or below that the projected horizontal line in the scope. So if you had a micrometer type rod with a little light or something right on a certain number, and you moved that up or down till it crossed the crosshairs, then you could still use an auto level, which is not a bad idea, because the good ones of those are like rated plus or minus a third of an arc second. Bouncing off the bridge would be, yeah, bouncing off the bridge.
Auto levels measure angles?
No, they measure the height above or below eye level by reading the target.
They measure the deviation from an established horizontal plane of the surface you're measuring to. An auto level establishes a horizontal plane and measures in centimeters or millimeters the deviation of the surface from that plane, no?
They let you read, all they do is project upon the scenery an eye level reference, and you can look in there.
Jesse, let me interject here, right? If I set an auto level up on a tripod at 4 foot, that isn't my eye level. That is a horizontal plane being established at a 4 foot level.
Exactly.
But it's not my eye level. I'm 6'2", Jesse.
Okay.
I do not have, my nipples are not my eyes.
Well, okay, you can squat down, and then your eye level will be down there, or you can put it up higher if you want. But
why can't you just accept that the auto level establishes a horizontal plane of reference? We all know that's what it does, Jesse.
That's what I just said, within plus or minus a third of an arc second. So let's say you say, how high do you want to set it up?
Is the measuring pole measured in arc seconds, Jesse? Does the auto level measure arc seconds?
No, it measures straight and level within a margin of error of plus or minus 1 or 0.3 or 1/3 of an arc second.
And where did you get the arc second measurement from within the auto level?
The manual.
What the manual? You got it from the from looking through the eyepiece, you got that arc second measurement from the manual.
No, but if you look in the manual,
Okay. Right.
if you
So
look,
when you're looking through the eyepiece, where do you get that arc second measurement from?
it's not a measurement. It's a margin of error.
Okay. And when you're looking through the eyepiece, how can you know that you're within that one? What was it? One
Point
something
a third of an arc second.
third of an arc second, which is that is a very, very, very small something to look for, isn't it?
It's a very small margin of error. Yes.
Yeah. And would you be able to see this third of a second when looking through the eyepiece of the auto level?
Well, no, you don't see it, but you just know, assuming you trust the manufacturer, that what you're seeing as a projected straight and level horizon or horizontal line of sight will be within plus or minus of a true straight and level line of sight. It could be
Right.
plus or minus 0.3 arc seconds.
So we're looking at a measuring rod. Right. If you go back to my screen share again, right, I'll get rid of these lines and I'll start again. So we have got a guy here with a rod. We've got a guy here with an auto level. He does a shot to the rod and he takes a measurement. Yeah, this is your datum. So this guy then comes to here. You with me so far? He's got
Okay.
his measuring rod. And you what do? You swing the auto level through 180 degrees. Yeah, and you just rotate it on the tripod. You don't need to reset it. You are working from the same horizontal position, yeah?
Okay.
Right, so you get your measurement. Then what? This has to come to here. Yeah?
Okay, I'm watching.
So you can take this shot to here, and then again to this one.
So are you moving the auto level?
You have to, don't you? You've got no choice. This is 200 meters, right? But you do it, you move the auto level at the least amount of times possible. So if we're looking at, 100 meters each way on your shot, 50 meters each way on your shot, is a total of 100 meters. Takes you near enough to the middle of the bridge. And then your second shot, another 50 meters, another 50 meters, takes you to the other shore. So you have to move the auto level once.
Well, and a big if, but if the Earth is curved, though, then that changes the auto level's idea of down, right?
According to you. Now, my idea of a horizontal plane is once that horizontal plane is established, then yeah, it'll change because there's a change in the topography, the thing that you're standing the auto level on. But then that can be adjusted out, can't it? So you continue that plane. Is it your understanding that you can form a horizontal plane all the way across this water using an auto level?
You could get pretty close in a single
You could
shot.
get pretty close. Right. Is Rakia in here with us?
And here's how you'd do it. You'd have to do it differently than the standard procedure for a level run is, though.
Okay.
I think Rocky is in another room. You want me to go get him?
It's okay, Jeremy. If he's happy up there, then that's fine. Yeah, do you want to walk us through?
Was happening. I missed a whole bunch of this. I forgot this was even happening.
Yeah, no worries, man. No worries. Do you want to walk us through that then, Jesse, if you would? How would you, what was it you were going to explain? Sorry, I was a bit preoccupied with Jeremy now.
Well, that's all right. You could set your auto level up at one side of the waterway, very carefully measure its height above the water. Like, say, how high would you like it above the water?
This is what I was saying with the auto level on this side over here. Do you remember when we were over here and I had your man with the stick and your not auto level, sorry, your theodolite was over here, and we were doing this. So yeah, and you were saying that it wasn't that easy to get that measurement from the horizontal plane down to the waterline, and now you're saying on this side that it can be done, that we can take that measurement up from the waterline to the horizontal plane, and then what, project that horizontal plane across there?
Just straight across the water.
Just straight across the water. So like that. Sorry.
Yeah, all the way to the other side.
So from one shore to the other.
Right.
And
now you won't be able to read.
Go
ahead.
Sorry. No. I was just going to ask you how. This is using an auto level, yeah?
Yes.
Right. So bearing in mind that it was my idea to do the transit here, how do you project that plane straight across the water? Because I thought using an auto level, working to 100 meter distances. So please explain how that is done then, Jesse.
So the optics on an auto level are absolutely identical to the optics as far as looking through the scope as they are on a theodolite, which is designed to go great distances. The catch with an auto level is you're typically looking at a yardstick ruler thing, and you can't read the numbers at 200 meters, 200 and whatever meters.
Mm-hmm.
But you
I have a quick. Sorry, go ahead. My bad. I have a question after.
You can still see a light. So what you do is you have on the far shore, you have a guy with the meter rod measured right off the surface of the water, and you have a tiny little pen light or something, a little LED, which the guy can see in the auto level. Now, he can't read the numbers on the yardstick, but he can see the little light, and he can say, move it up, move it up, move it down, and he can guide the other guy to move that little light right lined up with the crosshairs. Then you can see how high is the light actually above the water. So that's how you could use the 0.3 arcsecond accuracy of the auto level but using it kind of like a theodolite in that you're shooting at a target, not trying to read numbers, because you can shoot at a target at any distance if you can see it, because you don't have to read numbers. All you got to do to line it up. So that's why theodolites can be used on great distances, because you're not trying to read numbers through the scope, you're just lining up to a target. Okay, I'm done.
Right, and you're looking through layers of atmosphere as you get further away from the target, yeah?
Yeah, real quick. I'm just curious. If an auto level is made to only go this certain distance, but a theodolite is made to go a much farther distance, I'm just curious as to what's the difference, because I thought the difference was, I thought the problem with the auto level was you're looking through the auto level through all this atmosphere, which is going to, cause the light to bend, and you're going to see it up or down. I'm just curious what's different in the theodolite where this isn't happening. It doesn't.
Well, no, light effects are a problem for auto levels and theodolites all the same, because they got the same kind of telescope on them. They work basically optically the same. The reason an auto level is rated only for a certain distance is because beyond that distance you can't read the numbers on the ruler, and you've got to be able to read the numbers on the ruler looking through the scope. And so that's why a 24x auto level, that's the magnification of the little telescope, it'll be rated at a certain distance. A 32x will be rated at farther, because with the greater magnification you can read those numbers farther.
Does that answer your question, Jeremy?
Yeah, that's good, I guess. I don't want to derail this whole thing. Go ahead.
Right. So you're saying that you can make an indirect measurement, because again, a guy with a little laser pointer pen, it's not the most accurate way of making that measurement, is it, Jesse?
Well, it's the most accurate one I can think of, short of, laying out a long tube and drawing a vacuum in it, so there's no air to miss with your, no refraction possibilities. But other than that, I think it's a very good idea, because it allows you to find the exact horizon point, where that projected horizontal coincides with the height of that little pen light, and you don't have to read the ruler since you're using the little pen light, and yet you get the added accuracy, the third arc second accuracy of the auto level, whereas a theodolite that any of us could afford is going to be 1 to 4 arc second accuracy, or maybe even 5 or 10 margin of error, plus or minus. So I think it's a really practical, best way, because a plus or minus 0.3 arc second auto level doesn't cost that much compared to a comparable theodolite.
I mean, like that 32 times scope that I was using, I think that cost him about £100.
Right, exactly.
And that is the kind of the benchmark auto level. So it is fairly reasonably priced to be able to do something like this. Now, geometrically, Jesse, right? If we were, let me get my red pen again. If we were to measure a point here, and here, and then we were able to do this, then because these points would be in a plane, right? I'm hypothetically jumping the gun here and saying this is a plane. So because these 3 points are in that plane, then you know that this body of water is a plane just by that one triangle, yeah?
Well, I mean, you could put 3 points 1 inch above the surface on a basketball.
Now, Jesse, this isn't the question I'm asking you. The question I'm asking you is related to this body of water. There is no basketball involved. Please leave your basketball outside the room for today. So the question I'm asking you is that if we establish 3 points, coplanar, and measure that they are the same distance down to the water, then these 3 points being a triangle, and a triangle can only exist in a plane, then being equidistant from the surface of the water, then this surface of water must be coplanar. Oh, must be a plane, sorry.
So let me get this straight. We go to 3 points, we pound a stake right in the edge of the water where it's shallow, and each stake is exactly 1 meter above the surface of the water. Is that what we're talking about?
You survey it out, you establish a plane, and from that plane, the drop to the water level is equal at each point.
What if that doesn't all happen at once? I mean, if you're, where's your benchmark?
Well, you can set your benchmark anywhere.
So you're using an auto level to transfer your height from your benchmark to each of those 3 points?
You set the height of your benchmark and then establish the height of the water from your benchmark, and then off you go.
So I guess step me through the exact process. So where's your foresight and your backsight?
Right, Jesse, you would start, say here, Foresight to here gives you 1 point, and then you would leapfrog your pole. So your rod man comes here. You set another point. You haven't altered your auto level. You've just spun it, or your theodolite, whichever. You've just spun it on its plate. So your horizontal hasn't changed as you claim it does. You've got one measured point, another measured point. You have one on the opposite bank. You've got a triangle. Now the question I'm asking you is, this triangle has to exist in a plane. If you establish that there is a drop here, a drop here, and a drop here that is equal to the surface of the water, then the surface of this water must also be in a plane. Not the same plane, obviously.
To know, or to get an idea about what we would find, I would need to understand your procedure for where all your turning points and your observation points are.
I'm not a surveyor, Jesse, right? I've used the tools. Okay. Now I know that the tools establish a plane, and I know that if you measure down from that plane a certain amount, then on that plane, if you do that in two places and draw a line, you have two parallel. One's a plane, one's a line. The line is parallel to the plane. So if you can do that, then what is preventing you from taking it that one step further, forming the triangle? The triangle can only exist in the plane. You form the plane over the water, therefore the water is a planar surface.
Well, could you start your diagram over, but show me where your foresights and backsights are, and where your
Right. This is getting lost in a little bit of minutia here, which is where I didn't want to go, because you know what I'm trying to do is establish different ways that this could possibly be done. Okay, and we're just looking at. I can't. There we go. We're just looking at one method here. Yeah, as for setting up your benchmarks and your foresights and your backsights, and yeah, we can go into this in detail at a later date, right? But all I'm looking at is the practical usage of the tools. I appreciate you need to set a benchmark, and as I said, you can set the benchmark anywhere and work off of that benchmark. You could use the water level as a benchmark, couldn't you, Jesse?
Yeah.
Yeah, exactly. So you could use the surface of the water as your benchmark and just project your benchmark out.
So,
is that right, Jesse?
Well, yeah, but that could mean a lot of different things.
Exactly. So you set a benchmark from your water as the water surface and project that benchmark out. So, you're doing foresights, backsights, and turning points within those parameters. You're kind of going into the minutia that I didn't really want to go into. We can establish that this method can be used for doing this. That's good enough. Now, I have another idea that I don't know anything about, and this is laser leveling. If you had like laser reflectors here, 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 and you just had like a remote control boat or something, just and it's bouncing the level line backwards and forwards like this. This is another idea I've had. What we first need to do is establish the planar nature of the water surface. So if there's anybody else that knows anything about laser leveling and the limitations of laser leveling, distances and things like that, I have used laser levels before, but only up to a distance of about 50 meters. And again, this is nearly 200 meters. So, you know, you got 100 meters down the center. You're still 50 meters short on either side. So if anybody knows if you can use a laser level at a greater than 50 meter distance, I'd love to know. But what I'm trying to establish here, Jesse, is that 3 points in a plane make a triangle. Oh, sorry, 3 points in a plane. 3 points make a triangle, and that triangle can only exist in a plane. As can any Euclidean shape can only exist in a plane. A Euclidean plane, yeah?
Well, 3 points of a triangle may lie along a plane. They may even define a plane, but I don't see that doesn't inherently prove that some other object is also lying along a plane, unless it's measured to lie along that same plane.
Other objects. You're being a bit vague there, Jesse.
Well, defining a plane above the water doesn't really speak to whether or not the water itself is a plane.
Well, this is the entire point of this. You know, it's been billed as a presentation, but it's turning into a discussion, which is good for me. How do we make that measurement from the plane to the water surface? Now I've noticed that Rakia's just joined. Good evening, Rakia. Do you know anything about laser? Do you know anything about laser leveling?
I use auto levels that have lasers. I just use one.
Okay.
Like 5 seconds ago.
What sort of distances do your laser levels go up to?
I'll be honest, the one I just used, we use about 300 foot to 500 foot, depending on how much humidity is in the air. But they get off quickly. But they're very accurate short distances. I made a video this morning that was like 22 seconds long, showing from like 10 feet. If you just barely get the story pole off level, it's telling you you're off, you know.
Right.
But they do have their limits, like everything else.
And so it's a high degree of accuracy at a shorter distance. And once you reach that limit, then the limitations of the tool become obvious pretty quick. Yeah.
I would say it's more accurate than like anything else, like using a tape measure with a theodolite or whatever. I'm sorry, on auto level, but you know, they do have it. Once you get out of their limits, they get wacky. Like you'll be way off.
Right. And can I just
of course their line of sight.
Line of sight, yeah, yeah. And once that plane is established, that if you get 3 points in a plane is a triangle. Yeah, a triangle can only exist in a Euclidean plane.
We just squared up a 300 by 3. It was actually 300 feet 3 inches by 280 feet 3 inches, because we put a ledger strip on it for the drip edge for the metal. That's why the 3 inch and a half, you know, on each end. And we squared that up, and then, you know, check the diagonals, and if the diagonals are equal, it means it's square. And then we check the middle measurements also. So at each corner, we check and make sure it's the same measurement. And then once we square it up, we check the middle. And if those measurements end up being the same in each middle at the end, you know, your total overall length, then you verify that your diagonal was right and that you're building a square.
Building a square, right.
Yep.
And can I just recap on the conversation we had this morning over in Livestream 1? The hypothetical situation was you're giving a plot of land to build a house on. You decide a level for your slab, build off of that slab, and then you're given the project of the house next door. Could you level the house next door to the same level as the house you've just built?
I'll give you a real world example that had happened about 10 minutes ago. My other crew that's forming a house slab right now called me and said, you know, we're at the corner lot. What elevation do you want? And my exact words to them were the exact same slab height as the house next door. So there you go.
And they are practically able to project that plane from the existing house to the lot next door to establish a plane for your slab height to build off of.
Very easily. It's simple.
And you're given the plot across the road as another project.
If I wanted to check and see how high or lower that house was, you know, or if I wanted to make the same horizontal plane across the street, I could do that easily. Or if you want to know if the house 3 doors down or a half a mile away is higher or lower than what you're setting, then you could easily check that also.
And you would do that using what methods?
It just depends on how far you're going. I mean, if it's within the limits of what we're doing on that day, we could just shoot it, you know?
Right.
And I
So
would normally use a laser level for that because it's a one-man tool. You don't need 2 people.
so say it was a house half a mile away,
Uh-huh.
and they wanted the same slab height. How would you project that slab height half a mile away?
I could create straight line segments with the same tool. Either you know, take the shot of the 2 slabs that I want, that I have already that are horizontal to each other, and make a point in between them or diagonal to them, whatever way is closer to where I'm going, and then I could leapfrog or do any type of method that would close the loop, basically making that horizontal plane the same. You can go as far out as you want in any direction.
Right. Now, to me, Jesse, what Rakia has just explained and described here is one horizontal plane being projected over a distance. Now, that to me is a Euclidean plane. And yet you're saying to me that the surface that Rakia is projecting isn't adhering to that horizontal plane. So how does Rakia know that his new house that he's building half a mile away, the slab height is at the same height as the houses he's just taken that elevation from? Have you adjusted for any deviation from the horizontal there, Rakia?
No, that would make you off. And when you close that loop, when you come back onto yourself and you get the same reading, you know you don't have error, or you have lack of error. And any error that you have is usually not holding the story pole direct. Sorry about that. A phone call. Am I back?
Yeah, no worries. I think Jesse
You know,
can go on.
Yeah.
Me?
That was that was aimed at you, Jesse. Rakia's not getting any deviation from his established horizontal plane to his projected location for the plane.
I would love to discuss this with both of you again, but I have exactly 1 hour to go to the store, buy boots, get junk out of the van, load the prospecting equipment in the van, go pick up a friend, and get to the creek. So I am going to bid you adieu, and thank you so much, and I'll catch up later.
Okay. Thank you for your time, Jesse, and thank you for your input. It was
Certainly.
much appreciated.
Certainly, certainly.
Right. Okay. Now I'm gonna hop back to another screen now. I'm gonna go back to the Anchor Watt screen because I like Anchor Watt. It's change windows. So Google Earth. Right. There you go. You should have Anchor Watt back up on the screen. Now, like I say, this area is very special because if you can establish that a 1 mile stretch of water is a plane, then any orientation in that plane is still within that plane. So if you turn this stretch of water through 90 degrees, then that water, even though it is perpendicular to the water as it is now, is still in that plane. And for these two bodies of water either side, the perpendiculars, to be sharing the same plane, all they need is a coplanar section in each corner. And then once you've established that that is a plane, then the law of hydrostatics dictates that the surface of the water must adhere to the plane everywhere on that plane. And this is a natural law. Hydrostatics, the hydrostatics cannot apply in one place on the plane and not apply in another place on the plane. It doesn't work like that. And then once you've established that that is a plane, I mean, Angkor Wat is a mile square, near enough. It's near enough a mile on the longest side, and like I said, it's 0.8 of a mile on the shortest side. So it's actually a rectangle. But there are other areas in Cambodia, in this complex. I mean, this is, if I remember rightly, this is 6 miles long. So we have a body of water here. Oh no, I was wrong. That's 2.2 miles on that one. So it's 2.2 miles long. And just over half a mile wide. Again, it's a big body of water, and if you can project triangles one side to the other, you can prove it's a plane. A triangle can only exist within a plane. And then there is another body of water over here. Now, to measure these bodies of water, it would be best to go after monsoon, because they do tend to dry up. But I've kind of been thinking of something else, in that if we can demonstrate where are we? There is a stretch of canal. I'll tell you what, I'll do a search. Leads to Liverpool Canal. Leads. Right, so there is a canal. It's become quite a talking point over the past couple of years in this arena. The longest straight stretch on this canal is said to be 27 miles. Now, what I'm thinking, this is 0.1 of a mile. Let's have that in meters, shall we? So we know how many meters. 13 meters. Now this is well within the shot of an auto level. And all we need to do is triangles like this. So once you have 2 points of your triangle, I don't know, can you see my cursor at all? Anybody?
Yeah, there it is.
Yeah, we can see it.
Yeah, right, okay, that's cool. Hang on, I've lost my Google Earth. Right, okay, so you have 2 points of the triangle on one bank, the third point of the triangle on the opposite bank, 13 meters away. This is well within the shot of an auto level. And from that third point on the opposite bank, all you need to do is project back to the first bank and you are given a second triangle. And you just keep doing that, bouncing backwards and forwards across the canal. And you take measurements from this established plane to the surface of the water. And you establish, using these triangles to establish this plane and the measurements down. You know the triangles are in one plane because they're all sharing at least 2 points. Well, 2 points. So I'll just start anew, all right? So if we have one triangle here, this is your first triangle, and then your second triangle would be formed like this. Your third one like this. Your fourth one like this. So these are all triangles, and because they have common points, they must all be in the same plane. And taking a measurement from that plane down to the surface of the water, you can work this out as far as you want, going all the way along the canal, establishing that plane above the water and measuring down to the water surface. And you can even go around corners with it. There you go, you've taken your plane around the corner, so you are no longer in the same orientation in that plane, you are changing orientation in that plane, showing that that plane is a plane. Now,
DP, if
Yep.
I can just quickly interject. So this actually does sound familiar. Do you know why? Because
Hoymar, hang on a second, I've got to turn you up, sorry. Go on.
okay, so this does sound familiar because that's how triangulation is done in surveying. You know, if you look at how large scale distances are being measured, then it's exactly via these kind of triangulations, by building a network of triangles.
Mm-hmm. Where do you think I got the idea from, Hoymar?
Well, possibly from that, but the scale at which these triangulations are performed is much bigger than a couple dozen meters.
And what does scale matter with geometry, Hoymar? What difference does the scale matter to the geometry?
Well, to the geometry itself, it doesn't matter.
No,
But
that's all I'm demonstrating is a geometric concept. That the geometric concept I'm demonstrating here is that if you form one triangle in a plane and project a third point off of any of those 2 points, and Hoymar's I thought you deafened yourself there, Hoymar. Was that an accident?
Yeah, sorry.
Right. So if you create a triangle in a plane, so 3 points in a plane, we all know that a triangle can only exist in a plane, correct?
Yeah, I would say it defines a plane.
A plane, a Euclidean triangle can only exist in a Euclidean plane. I'll be more precise.
I agree.
Right. So you have 3 points on your Euclidean plane forming your triangle. If you take any 2 of those points and project a third point, you can form another triangle using that 1 extra point.
Okay.
Yep.
And that triangle defines another plane, right?
No, it's in the same plane. It's got 2 points that are coplanar with the first established triangle. Therefore, the third point is coplanar, seen as that forms a triangle in itself.
You do realize that 2 triangles don't have to be like their normals, don't have to be parallel, right? They don't have to lie in the same plane. They can be tilted towards.
They don't have to. Exactly. You can form triangles wherever you want, Hoymar, using 3 separate coplanar points. But what I'm putting forward here is you have established 1 triangle in 1 plane, and using 1 extra point and 2 of the established points, you form another triangle. in the same plane.
You can create infinite amount of triangles once you establish one.
Well, I mean, yeah, but the point is, how do you establish that your first triangle is, the plane of that triangle is parallel to the planes of the subsequent triangles?
You don't need to, Hoymar. The subsequent triangles are in the same plane. You are always forming your third triangle off of 2 established points in that plane. That triangle can only be in the same plane.
But didn't you just agree that if you don't know that, like, we don't want to presuppose that all our triangles will lie in the same plane.
We're talking about Euclidean geometry.
Well, no, we're talking about measurements in the field, are we not?
We're talking about Euclidean geometric principles, Hoymar.
Applied to the surface geometry of the Earth, right?
Applied to a measurement taken over a body of water,
which conforms to a level surface.
Well, this is what we're trying to establish, Hoymar. Whether your level surface deviates from that horizontal plane, right? So are you now trying to tell me that that horizontal plane deviates at the same rate as the water? You claim deviates.
So, sorry, what's your question? That the water deviates?
No, are you now trying to tell me that your our horizontal established horizontal plane would deviate along with the surface of the water?
Yeah,
right, because
yes, I would say that the water drops away from that plane. According to the
Right, okay. So the horizontal plane remains constant, i.e. a Euclidean plane.
Yes.
Right. And did you see the graphic that Armour did for me, or the 3D model that Armour did for me, that I showed at the beginning?
Yes, I did. That's pretty much what would be happening, except that, that the red plane would basically lie on top of the arc, so tangent to that surface.
Yeah, well, there was a horizontal plane put in by Armour. It just didn't show up very well, and I don't think my cursor was showing, so I couldn't highlight it. But he has actually put a horizontal plane in on that model. So what we are talking about is the horizontal plane that he's put in on that model. And that is the Euclidean plane. That is how these triangles are formed within that plane. Right? Now you're telling me, or trying to tell me, that there's something wrong with the way that I'm trying to form these triangles within that Euclidean plane.
If I may for a second, I just want to make sure I want to make sure I didn't miss anything. I don't want to straw man anybody here, but you had established a triangle. And then did you say you were going to use 2 points on that triangle to establish another triangle?
Yeah, just by in the same plane, adding a third point, and then
that doesn't guarantee that the new triangle is in the same plane as the first triangle.
Well, if the first triangle, all 3 points are coplanar, 3 coplanar points make a triangle, then if you project another point off of that triangle in that plane, it has to be in the same plane, doofus, no?
No. If the surface that you're using is not flat, then those 2 triangles will not be in the same plane.
We don't care about the surface. All we're doing is projecting a horizontal plane across the surface of the water using, in this case, we can use an auto level. How about that? The distance is so short, we can use an auto level.
Okay.
And we can project those triangles ad nauseum as far as we want along the surface of that water. Always, we can make a measurement down to the surface of the water, and we can see if there is a deviation from that horizontal plane with the water, surface of the water.
Right. That as soon as you change the point at which you're establishing these points of the triangle, as soon as you move to a different place, then you've got a problem.
No, I don't have a problem. You see, I fully accept that an auto level establishes a plane. No matter where you set it up, you are establishing a plane, and if you set up an auto level and you did your shots and you moved your auto level, you could share the same plane quite easily. Rakia does it day in, day out.
Right, but you're making the assumption that no matter where the auto level is, the plane that it establishes is always the same plane.
You can check that it is the same plane. There are ways of doing this. Rakia does it day in, day out.
He doesn't check it.
Okay.
All right. Now, how about this?
So are you saying surveyors can't establish a horizontal plane over a given distance?
No, that is not
what you're
what I'm
saying,
saying.
Doofus?
No, that is not what I'm saying.
Right, and this horizontal plane would be a horizontal plane and would not conform to the alleged curvature of your Earth, yeah?
Right.
Right, okay. So what distance could your surveyors set up a horizontal plane?
You can establish a horizontal plane for a very, very far distance. However, what you'll find over a very long distance is that the vertical is no longer perpendicular to that horizontal anymore.
Well, that's your claim that you can't prove, and this isn't where we're going with this presentation discussion. Okay.
I remember you said that one
Let's
time.
go to the discussion then. Because
I remember you said you can establish a horizontal plane, but why would you?
Yeah, why would you want to? Why would you want to do that?
All right, so now back to the discussion. Say you have this. Say you're at one point of your two triangle network, and you're looking at three other points. You have, from that one position, verified that those three other points that you can see coincide with the horizontal reference that you've established. Those 3 points would all lie in a plane that your horizontal reference is establishing. But if you then go to the other points and shoot back to any of the other points, you'll find that some of them have deviated ever so slightly.
Well, this is your claim. Have you actually demonstrated this?
Well, the main
Are
surveyor.
you a surveyor? Are you a surveyor, Doofus?
I mean, DP, let's just consider elevation. Right? Like, regardless of any curvature, elevation will cause just that. We'll have triangles that lie in planes that are narrow.
You clipped there for me, Hoymar. Can you repeat the last part of that sentence?
I said if your points lie, in different elevations, then your triangles will not be parallel.
But how can the points lie at different elevations? You are establishing a horizontal plane, Hoymar. They will be coplanar. They may be at a different elevation from the ground. Who gives a shit? The plane doesn't care what happens to the ground underneath it.
I mean, that plane is still presupposed, but actually, it's what we are trying to establish by taking measurements in the field, right? So there's no use in presupposing again and again that it should be a plane.
You're forming triangles, Hoymar. Triangles can only exist within a Euclidean plane. You are forming one triangle off of another triangle, off of another triangle, off of another triangle. Each time you form a triangle, you are using two of the existing points of one triangle, putting another point in the same plane, because it has to be in the same plane to form a triangle, with the two existing points of that triangle.
That's not true.
Well, that's your claim.
Right, you don't. Okay.
You obviously don't understand Euclidean geometry, then, Jeff.
I'm not Jeff. If you establish a triangle, and then whatever you use to establish the other 2 points from one point, if you change which point you're at and establish the fourth point to make your second triangle, if you happen to be at a different location, you have a different horizontal plane, that triangle can be in a different plane.
Do you want to prove that?
How do I prove that triangles don't have to be in a plane? Like
Well,
that two
this
triangles
is
don't
your
have to be in the
claim.
same plane? Are you
This
serious
is your
right now?
claim. This is your claim that you can't prove.
That I can't prove that two triangles can't be in, that they don't have to be in the same plane. Are you serious right now?
Two triangles that share two coplanar points with another triangle in a plane.
Yeah,
Okay.
if you just look
Two
at the
coplanar
Livestream
points is
text.
a nonsense statement. There's no such thing as there's no way to define a plane with only 2 points.
No, I said there are 3 points of the triangle, and 2 of those points share a plane with a third point not of that triangle. How can those 2 triangles not be in the same plane?
The answer is in the question you asked. Those 2 points can share a plane with that third point for its new triangle. That plane does not necessarily have to be the same plane as the plane that the other triangle that you already have is in.
Am I missing something here? Can somebody?
They're not.
Well,
they're not in the same
if you
plane.
want,
They're
if you want
sharing.
someone to speak up, hold on, just real quick. If you're asking for someone to speak up, I would encourage you, DP, to stick to your plan of action. Don't get distracted. If you want to entertain these particular questions from these particular persons, that's up to you. However, I think it would be best if you just continue to drive home what you know to be true.
Yeah.
He's talking about two triangles sharing a common 2 points. They're in different planes. Can you understand? Like a folded piece of paper. And the yeah, there you go.
Take the most extreme example. Put them at 90 degrees to each other. That's easy to demonstrate that that's a possibility.
Yeah, but you have to fold the plane.
I have to what?
You have to fold that piece of paper to make them at 90 degrees to each other. They are drawn as a flat piece of paper, and then you have to fold the paper to put them in opposing planes.
You can do it with paper that's already folded. That's the point.
For God's sake.
Dealing with,
why do you have to do this? Why, Jeff,
go ahead
why
and
do you have to
finish what
do
I was
this?
saying. Thank you.
Why do you have to run in circles like this?
It's not a circle.
Right.
So
we are talking about Euclidean geometry within surveying, Jeff.
Oh, for fuck's sake. Okay, I'll finish it anyway.
Well,
if you don't like it,
you can mute yourself.
Aren't we down here in Livestream too, so DP can do a presentation without being rumpus?
All right. Yeah. All right.
I mean,
Why
this
don't you
is
just
DP's
keep on going, DP. Finish your presentation, and then
Right. Well, to be honest, I'm just about done. You know, because this was kind of where I was going with it. In that we can form this string of triangles along the canal using surveying techniques, and then to guarantee that it is coplanar, we establish this, and then I'm looking and wanting to get involved with something called LiDAR. Now, this is a laser ranging laser. I'm tired, so bear with me. The acronym escapes me.
And ranging.
Thank you. Yeah. So what I'm kind of thinking is that we can establish that this all the way along here would be a plane, and then we place reflectors at different points along the water surface, and then with LiDAR. I mean, I'm looking into LiDAR. I want to get trained up with LiDAR, and I've only just scratched the surface with it, and it is looking to be a wonderful tool because it takes all the measurements that you make using standard surveying equipment, and you can scan it all into a point cloud, and that point cloud is then a planar representation of what you have just scanned, and it is true to life. It is a walk-through digital representation of what you've scanned. And if we can establish that the canal lies in a plane, and we can scan 27 miles of a canal with the LiDAR and put it all in a plane, it's already in a plane, and the LiDAR will register the rises and falls when you get to the locks at either end. It will represent that elevation level of that plane, and then if there's one lock at one end that rises, you go up, and that will be represented in that point cloud. The other lock at the other end drops down. That will be represented in that point cloud. And this becomes the truth of what it is. It's a planar surface. And if we can demonstrate that over this short distance, wherever it was, here it is, look. If we can demonstrate over a mile that the surface of water is planar in nature, and that's the important thing, right? It's planar in nature. The surface of the water is subject to the laws of hydrostatics. Hydrostatics is a natural law. So if we establish that the surface of water adheres to the plane, it is planar in nature. Well, it's rather that the plane is established from the surface of water, which is what we all know and hold to be true. You know, if somebody asks, if you ask somebody, is the surface of water a plane, a flat? Is it flat? They'll say yes. They won't say it curves at this rate or that rate, or if you walk that way, then you're going over. It curves with the ball. They don't associate the nature and the physics of the surface of water with where they live. And it's time to show them that the two don't add up. And I think there is a way of doing it with this triangle, forming the triangles within the plane, extending the plane. We don't have to go for these great big long distance shots. We can give Ruhif his mile long shot and see how the refraction messes around with what he's trying to measure at a distance. He's trying to measure something that is refracted to a position that it's not in, and it's not the size, that the true size of what he's trying to measure. I mean, Travis and Beerman, they've been going into the refraction and how refraction works, and you really should check out their stuff. Travis has done some really good studies over the past 2-3 years, Travis? Studying.
It's been since 2018.
2018, 4 years. 4 years. Travis goes back to the same place time and time again. Takes the same photographs, but they look completely different, and it's all due to refraction, to the air. You know, the subject in the photograph remains the same. It only looks different because of the atmospheric conditions. And we need to understand what's happening there before we start trying to measure shit over those distances. Trying to measure something we don't know what's happening to it over those distances with optical tools is a fool's errand. And clearly is into hydrostatics.
Are you roboting?
Am I? I'm in the kitchen.
Yeah, you are.
There you are.
Yeah. Yeah, so Travis is looking at the refraction. Clearly into the hydrostatics. We can go into that in more detail than I can. But I think the key is this triangulation, or these triangles formed within a plane over the surface of water and measure down to the water from that plane. And I think that's about it, gentlemen. Thanks for your time. Gonna open it up for questions if you want.
All right, my whole point in all of this is to just make you aware of where the conversation will end up going, which is that if you assume that the 2 points going to a third point must be in the same plane as the previous point you made, you're going to find out that if you make that assumption, people are going to look at it and disregard this whole thing anyway.
Well, like,
Okay.
that's your opinion, dude.
Yeah, Rukia, is there any way of guaranteeing that the points in these triangles all share a common plane?
You still roboting DP? Maybe stop the stream. That might help a bit.
Okay.
Rocky, is there any way to guarantee that these 3 points all share the same plane? I think that's what DP said.
Yeah. Yeah.
Well, 3 points will.
Yeah, 3 points will always be coplanar. It's that fourth point that we need to guarantee is in the same plane.
There's no reason to doubt it.
Well,
Well,
yes,
if
there is. That's why this conversation is occurring in the first place.
If you are using surveying equipment, then that is what surveyors do, no? They establish a plane and project that plane. Or are you saying that surveyors can't do their jobs, Doofus?
No, that's not what I'm saying. They
Okay,
can
so-
project one horizontal reference from one location, but that doesn't have to be coplanar, or it doesn't have to be the same plane when they move to another location.
That's why we're having this conversation, because statements like that are being made.
Uh-huh.
Right, because that's what surveying texts actually say, is that you're establishing a new horizontal reference.
That's what they say.
Yeah.
Mm-hmm. And do you have any proof of intersecting horizontals, which is what you would end up with? Can
Well,
you
deviating-
measure? Can you measure the angle of intersection between two horizontal planes?
Yeah, you can with reciprocal zenith angles.
No, that's not what I asked. That's not the answer to the question I asked, anyway.
Well, it is, because that's
No,
the same
I'm
angle.
asking you for the intersection angle between two planes, two horizontal planes. You claim. Now you've got two.
it's the
You've got
same
two
angle.
horizontal planes that deviate from each other. Which one is true horizontal? And where do you get your reference of horizontal for the two deviating horizontal planes, the two intersecting horizontal planes? You would need a third horizontal to reference those two intersecting, deviating horizontal planes from. Now, how many surveyors do you know that walk around with 3 horizontals in their back pockets?
All right, you don't need a third reference in order to measure the deviation between two references. That's ridiculous.
Well, because you can't measure the deviation between the two horizontal planes.
I already explained.
It's simple.
How, and also I'm not Jeff. I already explained how a reciprocal zenith angle shot gives you the same angle as the difference between those horizontals.
I've asked you for a direct measurement of the intersection of two horizontal planes. And not only that, I've asked you which one is horizontal. You're claiming they're both horizontal. Which one's true horizontal to get the deviation for the second horizontal?
Neither of them need to be true horizontal. They
So
are two
neither of them are horizontal. So why are you claiming
okay,
they're horizontal?
I can't really finish what I'm saying, right? I'm not allowed to finish what I'm saying. Is that how this conversation is to progress?
Because you're talking
Did
shit.
you drop your juice?
All right, let's try this again.
You're talking shit.
When you have that, thanks for your opinion.
You've got two intersecting horizontal planes.
Thanks for your opinion again. When you have two horizontal references, neither one of them needs to be, quote, true horizontal in order for you to measure the deviation between the two.
So why are you calling them horizontal if they're not true horizontal? I've never heard of a non-true horizontal before. Has anybody else in the room heard of a non-true horizontal before?
Has anyone else heard of a true horizontal?
Horizontal is a true.
Okay, you can add the word true if you want. However, horizontal references are only referred to as horizontal, not true horizontal. You're adding the word true just to try and make a weird point which doesn't exist.
Well, you've just given an example of non-true horizontals. I've never heard of non-true horizontals. You just brought that to this arena, right? So I brought the antipode to that. I brought a true horizontal because I believe all horizontals are true horizontals. Now you were telling me that there are untrue horizontals. Now, which of your intersecting horizontals is the true one and which is the untrue one? Please
Right, so
elaborate, because I'm a little bit confused at this point.
Okay, so in all of that, nowhere did I say is there such a thing as an untrue horizontal. You can straw man my position. I specifically said I wouldn't straw man you, but you go ahead and do it to me. Straw man me all you want.
You can cry foul all you want, Jeff. You did say that.
Still not Jeff.
I'm still waiting for you to tell me how you measure the angle of intersection between your two untrue horizontals.
All right. Would you like a diagram? Would that help the conversation?
Yeah. Draw us a diagram, Jeff, please.
I just need.
Still not Jeff, just so you know.
I just need a 2-minute comfort break, so please bear with me.
All right. So here's a diagram. Now, if those horizontal references in every location are parallel to one another, those verticals will all be parallel to one another. Now, when you measure the difference between the verticals, you're also measuring the difference between the horizontals. We understand that part of geometry, right?
How are you measuring the difference between the verticals?
Reciprocal zenith angles. That's what they're for.
Hey, I just was asking so I would be clear. I didn't want to have to straw man you.
All right. And the reciprocal zenith angles, when you add them up, it should be exactly 180 for a flat surface with no refraction. They should be greater than 180 for a convex surface, and they should be less than 180 for a concave surface.
And at what distance do surveyors take these measurements to eliminate as much of this deviation that might occur?
They're not trying to eliminate it, they're trying to measure it.
So they have no limit to how far they'll measure two vertical reference points?
Depends on what kind of measurement you're trying to do. If you get a bigger measurement or a bigger deviation, the farther away you go.
Right. Oh, hold on. So if they're getting a bigger deviation, the farther away you go, my simple question is, don't you think they'd like to eliminate as much deviation as possible? So how close are they going to stick so that they have as little deviation that possibly could happen?
They're trying to measure the deviation. They're not trying to eliminate it. There's no reason to go closer to eliminate the thing they're trying to measure.
All right.
And where was this diagram you were talking about?
I don't know. Some other people posted stuff. It's 45 after the hour.
It's in Livestream too. Livestream 2 text.
So you're pointing two tools at each other?
Yeah, this particular measurement is done with theodolites.
How many surveyors point theodolites at each other to get an angular measurement? And you've
how many
over what distance are you doing this as well, Jeff?
And also still not Jeff. Over however distance you want to, really.
So what distance would you say would be adequate to establish your intersecting horizontal planes?
What would be adequate? Well, I haven't actually done the math on that. Let me check real quick.
Have you ever done this?
The measurement?
Yeah, exactly. Yeah, that was my next question. So you beat me to it.
The math or the measurements?
Yeah.
Oh, sorry. I just had to.
No, you're good. You're good, Rikia. So have you actually done the measurement?
I've got a question for Jeff after.
And can we let him answer this one?
Yeah, after.
There is a question on the table for you, Jeff. Have you actually done this yourself? Well, we'll take his silence there as a no. He hasn't done this himself. So he is bringing something that he has never done. He is taking somebody else's word for this being able to be done.
Hold on.
And if you notice the
Oh,
picture,
there's
Hold on a
Jeff.
second.
if you
Hold on
notice
a
the
second.
picture, hang on, I'm
Because you
halfway
asked
through
me-
a sentence, Jeff.
Hold
I'm
on a
halfway-
second.
I'm
Because you
halfway
asked me to
through
go
a
do the math.
sentence.
Hold on. You asked me to go do the
Jeff.
math, and now it's time for you to rant about what I'm not answering while
Have
I was
you-
busy going and doing the math.
Have you?
So if you-
First
if you
question.
want to make this statement
on the
answer
table.
is not present, such that my position is forfeit, you're a dishonest cunt because you know I was going to go
Listen
do the
at him.
math. Right?
Jeff,
He's looking for a reason. Jeff always does this every time.
have you ever done this yourself?
Right. So you asked me a question already. I'll answer that one first, which is about the math. How far should we need to go? If we're trying to measure something to 4 arc seconds in accuracy, 400 feet should do fine.
Right, I believe the order of questions was the next question was: do surveyors point these tools at each other? At
Doesn't
themselves?
address the fact that they can. Like,
have
who-
you ever?
who does it in practice?
Excuse me,
Nobody,
I'm
really.
halfway through a sentence. Have
I was
you
already-
ever
I was
seen
still answering, though.
a surveyor point one theodolite at another theodolite?
Right. Yes. Sort of. I mean,
Yes,
the way
sort of.
you technically do this is you point the theodolite at a station. Then you go to that
Yes.
station. You can point that same theodolite back at the previous station.
Okay.
That's
and
illegal.
third question on the table was: have you ever done this yourself?
No, I haven't done it myself.
Okay, so you're taking somebody else's word that this can be done, has been done, and you are just going off the maths.
Right. I'm
Well
using
done.
surveying texts to tell me what people can do and have done.
So
and
you've read
as
a
well
book.
as manuals for the instruments themselves.
You've read
I
a
can go
book,
off
Jeff.
those because I trust those manuals.
You've read a
over your
book,
word.
just like the rumpus. Well done. You can read a book,
Right. But
you can't
when
go
we're
out in the
talking about
field
what
and
surveyors
practically
do
demonstrate it.
in practice, what surveyors do
can't-
actually do in practice is they
Do you-
can confirm curvature.
Do you need to speak through me every time?
No, you try speaking while I'm still talking.
Have you finished?
Go ahead.
So you have confirmed that you've never done this, and you are taking somebody else's word for it. You've read a surveying manual, like the rumpus has read surveying manuals apparently. He's read a book about it, and he is now an expert. The same as you, apparently. You've read a book about it, you're now an expert. You can tell all about deviating zeniths by pointing two tools at each other. That what the fuck are you pointing two tools of the same nature at each other for? Why? Who would ever do that?
Right, that doesn't
And-
address
but
the
you
measurement being taken.
You can't give me the intersection angle between two what you claim to be deviating horizontal planes.
Hold on, I did give that to you. Don't say I didn't give it to you.
No. You've given me some bullshit that somebody else has done for you. Now I'm asking you to go out there and measure it and bring the data back. You
Right.
think that this can be done. Get off your ass and go and do it.
Right, so if I go fire up a DM to Jesse Gordon, and then he comes back in here, does his measurement become more valid because he's here, or I'm the one relaying it?
Why are you running off in the weeds?
Yeah,
Like,
he doesn't,
we-
he,
You
he
need to
doesn't
do
want
it
to do the work
personally, and you
himself.
don't trust
spoke-
evidence from other people.
I have spoken to Jesse Gordon about his claimed measurements many times. He's been over to that Flat Earth Discord server and we've had some really nice conversations about it. We have ongoing conversations on a few different subjects. So don't tell me that if Jesse Gordon comes in here and spouts his shit the same as you're spouting somebody else's shit, that it makes the shit any more valid. Because at the end of the day, it is still shit. He spouts shit and you are spouting shit.
Right, and that's another opinion. Thank you.
Well, if you get off your arse and go and make these claimed measurements, and while you're out there, measure the angle between your intersecting horizontal planes. Don't go off what you think are diverging verticals. This is just ridiculous. And
right, if verticals are diverging, horizontals are by necessity not parallel with one another.
Well, this is your claim.
Well, if the verticals are... No, it's not just a claim. It's common sense, dude. If the verticals are diverging, then the horizontals cannot be parallel with one another.
Yeah, that is obvious. Yeah, but this
Okay,
is...
then. Don't say it's just my claim, then.
But this is your claim that this is what's happening. That is what's your claim.
It's not just my claim. It's the surveyors that are previously mentioned in this conversation.
Like who? Can we run through them? Let's run through them.
Right? Jesse Gordon, main surveyor, Jesse Kozlowski, I can mention now because he wasn't mentioned in the conversation yet. We can go through the manuals that say that's what happens over distance.
These are all YouTube surveyors.
I mean, they are on YouTube.
Jesse Kozlowski has done a runner. He's not here to answer for his crimes, as far as I know. Who was the other one? The drain surveyor? Well, that's you, isn't it? And the other one was who? The other one was who?
Jesse Gordon.
Jesse Gordon, yeah. As I said, I've spoken to Jesse many times. And
Right,
Jesse
so what
Gordon...
about the
Hang on. Wait there. I'm not finished. Jesse Gordon doesn't claim to be a surveyor.
Okay. He's used the tools.
He's just a hobbyist who rebuilds auto levels, theodolites that he picks up on eBay, takes them to the tops of mountains before getting them calibrated and knowing that they work properly to do long distance measurements.
Oh,
now,
boy.
why should
You're
I take
claiming
his
now
word?
that he hasn't calibrated
Why should I
his
take
equipment?
his word for anything?
Well, you're claiming now he has not calibrated his equipment.
He's admitted that he hasn't calibrated his equipment, so it's not my claim,
that,
it's his
that
admission.
needs a citation.
I'd like to just also add that the main surveyor's running around using non-calibrated equipment also, because didn't he take didn't he have two instruments set up side by side and at the same height and the levels and the level was off?
Yeah, nice one. Yeah. He couldn't even get his horizontals at the same horizontal, given two tools at the reticles at the same height off of the floor. He claimed.
Yeah.
A long distance
I
observation.
mean, what do you think about that? Yeah, what do you think about that, Jeff?
Still not Jeff.
Well, what do you think about it? Still not Jeff.
Right. If I remember the observation correctly, I don't think he used the same distance from the eyepiece when he took it with his cell phone. That was part of his problem.
What? He set his tools up side by side at the same distance off of the deck, and his two horizontals were at two different levels, Jeff.
Wait, are you? I think Jeff's saying that. I think Jeff is saying that the distance you are with your camera to the. Are you saying the distance that you are with the camera to the? Okay, are you saying that the camera distance would change where the horizontal line is in the theodolite or auto level or whatever he was using?
Tiny bit. Be a very small amount.
No. You think so? I don't know. I don't think so. Maybe.
Yeah, well,
can I ask a question real quick?
Hang on, can I just surmise there, Travis? You have highlighted 3 surveyors there, claimed surveyors. Still not Jeff. And of those 3 surveyors, one doesn't claim to be a surveyor, i.e. Jesse Gordon. He gets second-hand tools off of the internet and reconditions them, takes them to the tops of mountains and makes observations, and fair play to him. But they're only observations. Jesse Kozlowski has done a runner, and he's not answering any of the questions that are put out there regarding any of the observations that he's done.
Oh, it's
And
because the answers are already
the
on the
drain
website.
surveyor, the other one that you referenced in this conversation, can't even set his fucking tools up properly.
That's your assertion.
Now, have you... It's in a video he did. And he was that foolish that he actually put it out on YouTube. I mean, he didn't even recognise the mistake after the fact. It's like the calculations are added after the fact.
Well, it's funny you mentioned that because they have to in order to match the short range calculations or the short range measurements.
Yeah.
But
yeah, whatever.
So you don't want to address the actual measurements. You would rather attack the people instead of the measurements, right?
No, I'm not.
Yes, you are indeed attacking the person instead of the measurement.
Well, you have cited them as being surveyors. And they're not. The main surveyor is not a surveyor. Jesse Gordon is not a surveyor. The other geezer, whatever his name is, may well be a surveyor, but nobody fucking knows because he's not around to ask him. Now, you've cited 3 surveyors. Your trifecta. Where are they? Well, there's only one. There's only one. There's only one of any importance
the previous time. Oh, okay. I guess you paused for no reason again.
There's only one of any importance, and that's the Kozlowski geezer. The other 2 don't really matter, and that's no offence to you, Jeff, or to Jesse Gordon.
Still not Jeff.
Yeah, I know you're still not Jeff. You always will be still not Jeff. Okay, still not Jeff. I'm finished. Jeremy, you had sorry, Travis, you had something. Sorry, I didn't mean to cut you off there.
No, that's okay. I don't know if I'll break up in this pocket. Go ahead.
All right. How would
I took any of those 3 people and I brought them here by whatever means necessary to present the measurements that they have already published. What does that change?
Oh, go on, off you go. Go and get them. I mean, like I say, I've spoken to Jesse Gordon many times, and will do again. I'm speaking to still not Jeff now. So, if you want to go and get Jeff, still not Jeff, then I don't see how you're going to do that. But you know, and if you can bring Jesse,
have YouTube channels. Both
if you can bring Jesse Kozlowski
YouTube
back,
channels. I understand that you're talking, but I'll go ahead and talk anyway.
Yeah, I know you will.
He and I both have YouTube channels. Jeff and myself have YouTube channels. You can go listen to the voices on both of our public YouTube channels. Find out that they don't sound anything alike. And you're just being an ass this entire time just to call me Jeff.
Yeah, Did you
I'm just curious.
Hear their voices?
Sorry, Jeremy, you were clipping there.
I was just gonna say I'm just wondering how the camera being a different distance from the theodolite would change where the line is in the distance in the theodolite.
Well, that's an interesting question. I'm glad you brought it up.
If Jeff wants to answer that, yeah.
Well, I'm not Jeff, but
I'll be next after this, please.
Well, there should be silence right now if Jeff's not here, because he asked Jeff, I think.
Oh, for fuck's sake, Rakia. Thanks for the trolling.
Well, you piped up when he asked Jeff a question.
Is over whether or not, if the question is over whether or not the crosshair can appear to be in a slightly different position if the optical device improperly coupled to the eyepiece, the actual answer to that is one of your favorite, one of Flat Earth's favorite words, which is diffraction. If the optical device is off center from the eyepiece, diffraction will cause different elements of the background to appear around that crosshair. Only ever so slightly, of course, because that's what I said the first time.
Whose question that was? Jeremy. Does that answer your question, Jeremy?
Diffraction is the reason this would happen. All right, I'll have to look into that. We'll see.
Well, no, it's just bullshit. He just can't set his tools up properly. He had 2 horizontals at 2 different elevations off of the horizon over that distance in that observation. You just can't set your tools up properly, Jeff. That's what it is. Why can't you admit it?
Okay, still not Jeff.
All right, still not.
Did you know? Did you see if both of those devices happen to be the same optical magnification?
It's your video. You should know.
Not Jeff, as I mentioned. Do you know if those 2 devices have the same optical magnification?
Would the devices
If you have
not?
a tool, sorry.
I was just going to ask, would devices that are not the same optical magnification move the horizon from their horizontal position?
That's what I was going to say. Nice.
The amount that the horizon is off of the horizontal reference would change based on what optical device or what optical magnification the device has in terms of what you see in the video recorded by the device improperly coupled to it.
So what you're saying is if I had a 28 times scope and a 32 times scope stood next to, well, 24, 28, whatever, you know, you're the surveyor. You should know what magnification comes on scopes.
I never said I was a surveyor.
Can you stop being dishonest, 3DP? You're really taking away from your presentation. You started off good and now you're kind of making it bantering, bickering bullshit. And the Jeff thing's getting old, you know, as a listener.
What are you talking about getting old? Freaking hilarious, man.
Thanks for your input there, Phoenix.
I have some more input
much
on the
appreciated.
Anchor What when I get in, but I'll just put myself in the queue because I found some information I would like to go over with you.
Okay. Yeah. So you got a 22 times scope and a 32 times scope, yeah?
Well, 24 probably. I don't know.
24, whatever. Right. So are you saying if you set those 2 tools up side by side with the reticles at the same height off of the floor, then the horizontal position in the reticule in relation to the horizon would be different in each one?
The amount of separation, I'll say it again since it didn't seem to stick last time. The amount of separation between the horizon and the horizontal reference, as recorded by the device, not coupled to the eyepiece, that will be different in different optical magnifications because the amount of magnification of the distant scene is different in the 2 devices. I can't believe I have to explain this.
No, it was just a question. You don't have to get all hoity-toity about it. It was just a question. And thanks for the answer.
Hi, DP.
Who was that? That sounded like a Ruhif.
Did.
Ah, Ruhif. I put it back
in to say hi to Dave Gafford. How you doing, Dave Gafford?
And what was the point of that, Ruhif?
It's fucking Jeff bullshit. It is getting old.
Yeah, it was old 2 years ago. It's still old.
It should be moderated, honestly.
A moderator actually prefers to do it too. He likes it.
Yeah, I heard Jeremy do it as well. Anyway, thanks, Dave Gafford.
I don't even know who's Jeff.
Uh-huh.
Is that not your?
Not that geezer at the top of the room. That's not him, apparently.
As far as I know, there's a guy named the main surveyor. People have said that Doofus's voice is similar to the main surveyor. People have said it's him. Doofus says it's not him. I guess the main surveyor's guy's name is Jeff. Is that what's going on? So you guys are calling him Jeff because you think it's him, even though he says it's not.
He sounds like Jeff. He's got Jeff's. The way Jeff speaks, it's all there, Doofus.
It's all there. It's all public. We both have YouTube channels.
Yeah, okay.
You're just being an ass, even though we sound like each other.
DP, can I have a moment?
Yep.
Jeremy, are you modding here or is Bandy? Who's modding?
Bandy.
Bandy, are you here? I don't think he's here.
He was earlier.
He was. Yeah.
Is that Gio?
Yep.
Yeah, I'm here. Yep.
Gio, Ruhif just used my full name more than once. Can you take care of that for me, please?
Yeah, I didn't know what he was saying. I thought he was trying to say that was DP's name or
He
something.
said my first and last name more than once.
Could you repeat it for us?
I could. I'm proud of my name. I have no problem, but I want him taken care of. Please, thank you.
Well, he's not in the voice
so
channel right
proud
now.
of you.
What would you like us to do?
Just be aware. I didn't know. I'm driving, so I don't know who's coming and going and using my full name on your server. But
Yeah, no, I mean, if you, I mean, I've heard you say it as well, but if you don't want it
stop
said,
all that. We've been through this. Ruhif knows it, right? He did it on purpose. So do what you want to do.
If you're requesting not to have your name said, then it would be considered doxing. And yeah.
You mean again? So yeah, I've requested it many times. I requested it earlier today when another guy who does it on a daily basis did it again. And I think Jeremy's going to get with you on that guy. I think it's Ned Hug or whoever that does it every day. So yes, it's been requested. He came in here. His first words were basically my full name, more than once.
It was his only words. That is the only reason Ruhif came in here.
Yeah, he came in here to dox. So if just it's your server, man. I don't want it to turn into a doxing thing. Thanks.
And seeing as it's prickled people, Doofus, I'll just call you Doofus. Because that's what you are to me. You're a Doofus.
He prefers Doofus.
Yeah. If you prefer Doofus, I'll call you a Doofus. Fair
Just
enough.
real quick, for the record, Rakia, yeah, absolutely. We don't want to allow any doxing. And if you don't want your name being said, that's definitely not allowed. So, I mean, I can give Ruhif a warning, and those add up. I can DM him. I can ask him. I mean, the only other option is to ban him from the server. But, I mean,
you could do that. I mean, is
Yeah,
doxing
I
a
wouldn't
bannable
cry
offense?
about that one.
Is doxing a bannable offense here? I mean, I asked Jeremy what the rule was earlier. I mean, is it a warning or 10 warnings? Can they do it 10 days in a row and then they get banned, or what's the rule? But we don't have to go through that here. Just let me know what the rule is. Thanks.
Travis, did you have something? Oh no, it was Faithful Phoenix. You had something regarding.
It was me if it was me if I'm coming in.
Yeah, you're good.
Is Doofus still here?
Doofus is still here.
All right. So I thought about my question earlier to you, and I think I want to try to clarify. So if you're taking, sorry, hold on. If we're citing two verticals, is it going to complicate or simplify those sightings if we increase the distance?
The thing we're trying to measure is the deviation between the two, and the deviation increases with distance. So
asked
really
and not
it
answered.
simplifies things in order to make the distance longer, in order to measure the thing that we're trying to measure.
Asked and not answered. Okay.
That's the answer, whether you like it or not.
It
does
simpler?
simplify things to make the distance longer in order to measure the thing that you're trying to measure. In order
So
to say that's not an
increasing-
answer is somehow very super dishonest to me. Anybody else want to catch on that?
Okay. Is it simpler to increase the distance, thereby increasing the work to worry about refraction or other things that might come into the sighting? My question is, wouldn't it be simpler to take shorter sightings, eliminating those other variables? Because if you increase variables, you would actually, I think, increase the complexity and work that you would have to do to make sure you're doing things correctly.
I don't
Right?
see how asking the same question again expects a different answer.
I'm just trying to be clear on the fact that you are saying that increasing the distance and increasing the work makes things simpler. Okay.
Yeah, because if you're really close, the deviation is 0, as it should be.
How close is close?
Right? Right on top of each other. That's pretty close.
So
right?
maybe it's maybe the verticals are parallel, and it's just that the farther away you get, it's the atmosphere affecting it. Is that a possibility?
Well, you could entertain that possibility, except when we measure the atmosphere, it doesn't support that idea.
Can I pull this back to the whole point of my presentation was to try and establish a way of measuring the deviation of the water level from an established horizontal plane.
Absolutely. I'd like to touch on something with that. What's this LiDAR thing you were talking about? I've heard that word thrown around a little bit here and there, but I've never really gotten into it. Is that like a...
Yeah,
LiDAR.
LiDAR is like the laser. I can't remember the acronym off the top of my head. It's been a long day. And what it is it's a digital scan. It's 2 million laser points in a second, sent out and returned. It gives you a point cloud. Everything that the laser intersects reflects back at a different frequency. So in the point cloud, everything is represented in a different color, and you can isolate different aspects of the point cloud and eliminate them. So say you did a scan of a farmer's field, for instance, you could eliminate all the vegetation because it reflects back in a different color on the point cloud representation. You could isolate all that out of the point cloud representation. But the point is that it represents as it scans. If it scans a flat and level surface in the point cloud, it represents it as a flat and level surface. If you go up in elevation in the point cloud, you go up in elevation. Now, if we can survey the canal and establish that the water surface is planar, and then scan the 27 miles of the canal with LiDAR, and as I said, this is something that I'm getting into and I want to get deeper into. The basic LiDAR setup isn't that expensive. So I'm trying to train myself in the understanding and the use behind LiDAR. To me, it appears to be a very useful tool in this situation. Because
I think I've seen him use this. My bad.
Yeah, it's becoming quite popular now.
I think I've seen him use it.
Drones. Sorry, Jeremy.
I think I've seen him use it to scan like crime scenes and shit. No, you ever see him do that?
Yeah.
Like, could be a dead body on a bed and it'll pull this thing out and it'll scan the whole room.
The whole room.
Same thing, or?
Yeah, and what it does is it gives you a digital representation of that room as it is, as a point cloud.
That could be slightly different. That could be a handheld laser imaging. So, like creating a 3D model of a room. It's kind of similar to LiDAR, but rather than laser points, it sends out a grid, and wherever the grid touches, because I work with 3D printing, so I know about.
Yeah, so do I.
Stuff like that. So it's a little bit different. But LiDAR, I know that you can get UAV LiDARs, because a friend of my brother's from Sweden came here and started a drone company that did aerial surveying, and he had LiDAR systems. Yeah, so I know now that you can get them for kind of retail prices.
Yeah, and LiDAR will do exactly the same as you said, that 3D scan of a room, the inside of a room. LiDAR will do exactly the same thing. Only LiDAR will be damn sight more accurate than a 3D scan of the inside of a room.
Yeah. DP, I got a quick question. I got a quick question for you before I go to bed. I just want to confirm when you're building the triangle platform across the canal, are you measuring then? Say you've built your first triangle. Are you measuring now a 90 degree angle from that platform to the next point, from those 2 points to the next point triangle? Or are you measuring from the water level to get to that next point. The reason why I'm asking, because if there is that curvature that they're saying, and then it'll conform to that curvature. But if you're building from that platform, that should carry on with that plane that you're talking about. So if you go from the platform 90 degrees and carry on, next platform, carry on, next platform, then there'll be a deviation to the water, that the water will be a lower distance from the platform down. Do you understand what I'm saying?
When you say the platform, do you mean like the reticle, the viewing eyepiece, and the crosshairs within? What you're doing is you're establishing the horizontal plane on that reticule, on the crosshairs. So the crosshairs are that horizontal plane, and your measuring rod
cool. No,
is
100%.
is that third point.
Yeah, no, then I got it. Cool. No, perfect. Thank you.
All right.
All right, but then I'm going to head off to bed. Thanks for the presentation. It was fantastic.
No,
but
thank
yeah,
you.
it's late my side. I'm going to head to bed now.
Yeah, thanks for joining us.
Cool. All right, cheers, buddy. Bye.
Thanks. And there was a question, Phoenix, you had a question about Angkor Wat, going back to Angkor Wat.
Yeah, I was just, I mean, at a first glance, you'd think, wow, I mean, that's pretty amazing, you know, flat water, square-ish, you know, rectangle shape.
Yep.
And then you realize that it's, you know, 55 meters above sea level.
And
just doing a cursory search, you know, just using basic elevation data, there's a 1 meter deviation from one end to the other.
In the land level, yeah, and deviation in the water surface.
No, in the sea level elevation difference. So
okay,
the elevation of sea level is 55 meters on average, and then there's a deviation of 1 meter across Angkor Wat's water using elevation data. So there's already a deviation there. There's already, you know, and as you click along, it's incremental. So it's slowly going down. So it's not flat.
Right. So the land around the water isn't flat. And your point is
the land at the water's edge, where the water is, you know, in the dead center, it's about 55, you know, and then you get variations up to about 56 meters.
In the land, either side of the water.
That's the water. That's the water. Then it was surrounding land, say, you know, just up north or whatever, you know, I guess north, you know, or if
right, so
it would have been on the left-hand side. That's still 55 meters. But keep clicking around, you know, and then it begins to drop off back to sea level towards as you go closer and closer. So the land is elevated above the water, and even the travel guides say that Angkor Wat rises up out of Angkor, you know, out of the place itself. So it's elevated, and then there's, you know, a segment where the water's being placed. So, you know, it's still not flat. If it was sea level, it might be something. But
okay. Well, this is kind of skirting around the whole point of this presentation, right? I'm looking for a measurement in the deviation of the water level from the horizontal. I don't care what the land's doing. The land can do whatever it wants.
Well, the deviation is about 1 meter.
What, in the water across that mile?
Across the water, yeah.
Well, you can't trust that then, because according to your ball, it's only 8 inches in a mile. So how come you've suddenly got 1 meter deviation?
Is the water sloping?
It's elevation of the land underneath the water to wherever the water level becomes.
So what's your point there? You know, you're looking at the elevation of the land underneath the water, not the water surface.
Well, it's not flat though, is it?
What, the land underneath the water isn't flat?
Well, because you're not, you know, the curvature is based on a sea level. You know, the sea level is where you would be, you know, measuring the drop. You're already starting from an elevated position, and the land contours. It's the topology of the land. The contours of the land itself is dictating the height of where the water sits and everything. But it's above. It's like like kind of like building something. It's like a bulge on a surface. You know what I mean? It's if it was If it was
hang on. I can tell you're struggling here, right? So let me let me just
struggling, I'm just
clarify. Let
saying,
me just clarify something a
55
second, right?
meters is a lot, dude.
Let me just clarify something. I don't know whether you were here for the point that I made that Angkor Wat is a square. Okay? It's not actually, it's a rectangle, as you rightly pointed out. But it has 4 straight sides. Okay? In this case, it actually has 8 straight sides because it is a square within a square. So if either side of the thinner strips of water are a square and they lay in the same plane as the opposite bank, then they are 2 squares within the same plane. And because each strip of water, you got 2, the top side, the bottom side, and the 2 edges to form your rectangle. Now, did you miss the bit where the corners are intersecting planes?
Well, if you were to draw them on a 2D surface piece of paper, 2D map, yeah, sure, they would be planar. But to say that to point at your image and go, look, I can create a plane here. Yeah, theoretically you can.
But this is my whole
point.
point.
That the land itself is straight.
This is my whole point to this presentation, right? We have, in Angkor Wat, we have a place where we can measure the level of the water being a horizontal plane. We can establish a horizontal plane there, and then in those corners, if they are shown to be planar surface of water, in those corners, the 2 planes intersect. Now, Angkor Wat is a little bit wide for doing it the way that I want to do it, as in the straight shot across the water. But the canal is only 13 meters wide. And if we can demonstrate that the surface of water is planar in nature on the canal, then by the law of hydrostatics, it must apply to all water everywhere. That includes Angkor Wat. That includes any lake. That includes any swimming pool, any bath, glass of water. All surfaces of standing water must be planar if we can demonstrate one surface of water over a distance of up to a mile does not deviate from an established horizontal plane.
I can show you sea level elevation to a mountain 2,885 meters tall, and the observation is 114 miles long across the water that separates the 2 islands of New Zealand.
Okay.
Now that is a significant amount of distance.
That's an
of
observation.
Water. It's an observation with an
I want
elevation
direct
profile.
measurements. The title of this presentation was how to measure the deviation of the level line from an established horizontal plane. Not look at it, how to measure it. And the only way you can do that is at close quarters, i.e. 13 meters across a canal, establishing a plane and measure down from that plane. You will not establish the horizontal nature of the surface of water by looking at it.
But what you will establish is that the entire top of the South Island of New Zealand is missing, along with all the mountain ranges leading up to the tallest mountain in that southern range. And you'll notice that over 2,000 meters of mountain is also missing. And then, as it shows, the elevation profile is logical. You want a direct measurement. We're starting with sea level.
I'm not interested in sea level. You can establish a datum on a canal. You take your measurements off of the datum. You can use the water of the canal as your datum for your horizontal plane. You could do that at both ends of your measurement.
You're wanting to use a constricted piece of water bound by a 13-mile wide constricted organically formed piece of land comparing it with two islands separated by what's known as Cook Strait, connected to the oceans.
That you're looking at. Not measuring, you're looking at them.
What do you mean we're not measuring them?
You're
we
looking,
know the
you're look-
elevation. We know the elevation of the mountain, and we know the mountain ranges leading up to it, and we know what we can see, and we know what we can't see.
Right, okay. You are taking this into the realms of refraction now and optics, okay? Lensing, whatever, right? This isn't what this presentation is about. But Travis and Beerman, I believe, are putting together a presentation for this server, I believe. Don't quote me on this. Regarding exactly what you're talking about and how it affects the optics of the instrument that you're using to make these observations. And my close quarters measurements using Euclidean geometric principles over the surface of a body of water eliminate all refraction. It's a direct measurement of the surface of the water, which we can confirm to be planar using LiDAR.
Right. Okay. So I live in New Zealand.
Okay. Well done.
I've crossed the boat that crosses the Cook Strait, and while I was on it, I never saw the top of the South Island to where I was heading, even though I was on the top of the boat looking out in all directions without any obstruction on a very, very clear day. Not in the morning, not with refraction, none of these things.
Okay,
Now,
right.
Now,
okay.
let me explain. And as we came over, we over the horizon, we could see the South Island. But the observation I'm talking about is missing the entire top of the South Island, and the mountain range and the summit is clear as day. And you can never see the mountain on any given day. So it matches the curvature, it matches the equidistant nature of the sea level leading up to the other end, and it matches the fact of the amount of hidden mountain calculated by the size of the Earth.
Right.
As
okay.
it's stated in the globe model.
Good points. Really good points there. Right. I appreciate that you are doing this. You're making these observations, going out on the ferry boat, looking to see whether you can see South Island when you're halfway from North Island. Right. I've done the same. Many times I've been on a ferry from England to France. And I've got what I consider to be halfway across. You can't really tell what's halfway across and what isn't. Look back at England, looked across at France, look back at England. Wow, you can see the shoreline on England. Look back at France. Wow, you can see the shoreline on France. Okay, it's an observation. I want first order measurements. And I think I've found a way to make those first order measurements. Now, you can disagree with my methodology, my method of doing this, right? But what you are talking about is a long distance observation that is subject to refraction that really doesn't prove anything, as far as I'm concerned. Now, wind it in, bring it to first order measurements, local, doing 13-meter shots with an auto level.
Across the water.
And a measuring rod.
Across the water between the islands of New Zealand. You want me to float out there and do measurements?
No, you obviously weren't listening to what I said. You obviously weren't listening to what I said.
Use sea level, and then we begin with the land, right? Elevation above sea level, first order measurement.
You don't need sea level to make a first order measurement. You need an established datum, which would be the canal water, and then you make measurements off of that datum.
Right, so you're trying to find the curvature, the 1 degree of curvature in around 69 miles, and you want to use 13
not at all.
meter wide. How long is the canal?
No. Not at all. You obviously didn't listen to anything. I'm looking for that 8-inch drop over a mile, or the 7 and a bit inch drop, however you want to consider it. Ruhif has actually given us numbers that at 100 meters, what we should find deviating from that horizontal plane. At 200 meters, the deviation we should find from that horizontal plane. 300 meters, 400, 500, 600. All the way up to, I think it was maybe 2,000. No, it wasn't that far. It was quite a distance.
Okay,
It's a long time since.
meters.
It's a long time since I did the graphic.
Sorry, no, much more than that. 183,600 meters.
What are you flapping about? What are you flapping about here? What is?
That's how long the observation is, and you want to use a small little bit of water that is dictated already by the land and the way it's formed around it. It's
why does the land?
Why don't you start at the ocean or something? You know.
Why do you think the land dictates what the water does? Is the land subject to hydrostatics?
Nope.
No.
So we
the
use
water,
sea level.
The water does what it does.
Mm-hmm.
It either conforms. It either conforms to the curve of your ball, or it doesn't.
And that's what I've shown in my observation. In my elevation profile.
If it does, I wasn't finished. Finished.
Sorry, dude.
If it does conform to the curve of your ball at the rate you say it curves, then it will be measurable at 8 inches for 1 mile. It doesn't matter how wide that strip of water is. 13 meters is plenty wide enough to form a plane. And using the triangle method that I have outlined in this presentation, conversation, call it what you will, we can establish that drop, alleged drop, from the horizontal plane. And then, like I said, blitz it with radar and it puts it all where you need it.
You mean LiDAR?
LiDAR. Mm-hmm.
Sorry.
It's late in the day here and it's been a long day.
Just for the listeners out there, just make sure.
Yeah, LiDAR.
Right,
now, I appreciate your long distance observations and bringing it up here, right? But that wasn't the point of this conversation.
Just a comparison, right? It's like you're using the 2 mile Angkor Wat 55 meters above sea level on average, and I already just by a cursory search found a 1 meter deviation in the elevation of the land, which dictates where the water's going to be sitting. So that's already a problem.
How does the land dictate what the water does?
All right.
The water's sitting on top of the land.
The water is sitting up on top of. No, it's inside.
But if you had a pool, right? If you had a pool and you filled it with water, it's only going to fill to the top of the pool line before it starts going in over and into the land, right?
Right. Yeah.
If your pool was made with a 1 meter elevation deviation from one end to the other because it was made like in the 7th century or something, when you fill it with water, it's going to deviate by that amount. But the downward force on the water is going to keep it exactly where it is.
Hold on, it's okay. So if you're going to construct a pool with a raised side or a raised end, so like say you make a rectangle pool, and on one side of it you raise the edges. Okay, so when you fill the water up, the water is going to be level all the way across, but at the one end it's going to have a higher edge. What's your point?
Well, that's what I'm saying. Right there shows that the Angkor Wat, based on that logic, is not planar.
No, we're not worried about
planar.
No, we're not worried about what the ground is doing.
Yes, you
we're worried about what the water does.
Unless
right?
that water just fills from the ocean and it comes up naturally from some magical spring. No.
No, and you don't get the point of me using Angkor Wat, right? I was only using Angkor Wat as an illustration of the ability to maybe measure those intersecting planes in the corners of Angkor Wat. And if you can establish that one strip of water in Angkor Wat is planar, and a second strip of water in Angkor Wat is planar, and they share that intersecting plane in the corner, they are both coplanar, i.e. in the same plane. But what you have to do is you have to establish the planar nature of water first. Then you go to the canal, because it's only 13 meters wide, and you can do a direct shot backwards and forwards, backwards and forwards, backwards and forwards across the canal, using triangles to establish a plane and measure down from that plane to the surface of the water. We're not talking about the land, only the water, and see whether there is a deviation in the surface of that water from the horizontal plane.
What happens if horizontals at different locations are not parallel with one another? You end up with the same result.
Claim. This is
right,
your
but
claim.
You end up with the same result.
Well, prove your claim, doofus.
Okay. But the whole point of this discussion is to determine whether or not there's any merit to this. If you do these triangle setups, then you could carry on along a body of water. You'll find out that you're following a level surface over that time because you're making smaller triangles.
A horizontal is what we're forming.
Right, not just one horizontal.
We're sharing straight line segments. You can even double rod it if you want, doofus.
Right, that doesn't make it flat either.
No, it makes the horizontal horizontal.
At one location.
You confirm the horizontal.
Right, but just for the sake of argument, if horizontals are not parallel with one another at different locations, your described test would end up giving you the exact same result, in that the water didn't deviate from your established thing that you just made, which isn't a plane.
That's why I want to use LiDAR.
Over what distance?
No, you can walk the whole 27 miles with the LiDAR, and it'll give you that canal as measured in the horizontal plane.
So you're doing the LiDAR from one end to the other.
Doesn't matter. You can work from the middle of each direction. You can start 2/3 of the way down and double back, do the last third last. First third last.
Well, you can't start in the middle. If you start in the middle, your two ends will be at the same deviation from the local horizontal.
With LiDAR?
Yes, if you start in the middle, your two ends will be deviated by the same amount.
It might actually be better to start in the middle, because then you can demonstrate that from the middle, the two ends would be in the same plane.
Of course they are. Even on a spherical Earth, they would be.
But in the same plane?
Yes.
You're claiming the
2 points can be in the same plane. That's perfectly allowed on any surface.
All right, so that plane that you're talking to over that 27 miles would be then what, the chord, or
right? If you're establishing a horizontal reference in the middle, your two ends are going to have the same separation from that horizontal reference. It's going to look identical from one end to the other.
Yeah, but in a LiDAR point cloud, then that would show as not being horizontal.
Right. You would see drop from horizontal with respect to distance, just like you do over any other observation. I mean, Bev even showed you horizontal or drop from horizontal with respect to distance. Oh, and then he blamed you for it too. That was funny.
No, he actually blamed me for the setup. And the setup was his idea to have the tower in the background. But we're not going to get into this petty argument here.
All right, but if you're asking what would you get? And the answer ends up being drop from horizontal with respect to distance. I wouldn't be surprised because that's what you get in any other optical method.
Well, LiDAR isn't optical. It's laser. It's
Whoa,
a point. It's point
hold
finding.
on.
It's point cloud developing. Everything is done in straight lines.
You might want to walk that back before you stick your foot even further in your mouth. You're saying lasers are not optical.
It's a range finding device. It uses laser light.
Optically.
200,000 of them. I think I said 2 million earlier. I think I over-exaggerated a little bit there. It's 200,000 points of laser light, all straight lines, to generate a point cloud.
So suddenly refraction does not exist because you use LiDAR.
Because you use laser.
Yeah,
Laser.
lasers are not immune to refraction. In fact, we demonstrate refraction with lasers.
Yeah, in sugar water solution. We don't live in
air.
sugar water. We don't live in sugar water solution.
Right, we demonstrate it in air too.
Mm-hmm. I've only ever seen straight lasers in air.
Okay. Well, then I got a perfect demonstration for you.
Okay.
I'll post it here in Livestream 2. It takes a minute. There it is. Now that dot that's on the far wall was emitted from that laser pointer that does change its direction in air.
Hang on, I'm just scrolling down to it. I've not been watching. Oh, and you're talking about if you can see the laser beam bouncing off the bottom of the iron there, Doofus. That is so disingenuous.
Yeah,
what he's
at
actually
one
doing
point-
is reflecting the laser beam off the bottom of the iron to move it on the whiteboard at the background. It's nothing. The iron probably isn't even plugged in. How do you
no, he
know
did
that
this
iron's
test.
plugged in?
Yeah, he did this test with it off and with it on.
Right, okay. But
in
you
this
can see
particular
you can
example,
see the laser pointer.
In this particular example, you can see
the laser
you can
bouncing off the bottom of the iron, Doofus.
Uh-huh.
This
Yeah,
is a
you can
really
see- you can
disingenuous
see-
example.
All right, I'll get it out anyway, since you want to
Yeah,
just
I'm
keep
sure you
going.
will.
Go ahead,
I'm sure you
get
will.
it out anyway, since you want to keep silencing me.
Don't
We'll
spill
try
your
this
juice
again.
bottle.
We'll try this again if you want to just keep
Don't
silencing
spill
me.
your juice bottle, doofus. Hold on
All
to your
right,
juice
well,
bottle.
but we'll just keep doing it if he's just going to keep just talking over me.
Keep your
All
toys
right.
in the pram,
Now,
Doofus.
now let's try this one more time. You can see briefly that the laser does impact the bottom of the iron, and for all of the rest of the loop where the laser is not impacting the bottom of the iron, you see that the point on the wall shifts position. So when you say it's because the bottom of the iron, you're being dishonest.
You're being dishonest by presenting this, Doofus. I
That's
don't know.
your
I don't know
opinion.
how you can. I don't know how you can do this. I can't see your face, but I presume you've got a straight face. I mean, you did almost just spit your dummy out and chuck your toys out the pram because you were being picked up that this is a disingenuous video.
Well, I think if you really wanted to see if it was disingenuous,
Beeble, who asked
try it
you?
yourself.
Beeble,
You
who
could
asked
actually
you?
try it yourself.
Oh, can we
Hang
get some
on.
moderation here, maybe?
Doofus, give me a second with Beeble. All right.
No, because he started talking. He didn't even get a chance to finish 2 words. He didn't get a chance to finish 2 words, and then you cut in.
Do I have
This is how conversations occur on this server, correct?
Do I have to mod you, Doofus? Do I have to
You can
mute
go
you?
ahead. You don't get to just say whatever you want to say when somebody says 2 words.
Right.
This is DP's presentation. He's live stream hosting this, so he is allowed to decipher how the conversation goes. It's not an open panel right now.
Thank you, Gio. Beeble, you challenged me to a debate over a year ago. Since then, you have been running from me to do that debate. I'm not interested in anything you have to say. Is that clear? Thank you. I take it your silence as acceptance. All yours, Doofus. What were you saying? Sorry.
So you could check, which was he is about to say, you could check to see if that happens. You could use any device you want to establish a gradient, much like this hot iron is doing. See if that laser light does deviate in air. And lo and behold, here in reality, air can bend light. It's not a problem. I've seen a hot car roof do it, but to you, it's unheard of.
So is it the air or the disturbance of the heat in the air bending that light, according to you, Doofus? Would that light do that if the iron was off?
The light would not change direction because the air would be of a uniform density. The air having a different density, is what's causing the light to change direction.
Well, what I can see is the light bouncing off the bottom of the iron there, as demonstrated in the video that you have provided. Thank you very much.
Right, and for the rest of the loop that does not impact the bottom of the iron, the laser point does shift position, so it's not due to the bottom of the laser or the bottom of the iron.
All right, okay. So how do you know that the laser isn't being reflected off of the plate of the iron through the rest of the loop? It's moved from the bottom of the iron and is going along the plate of the iron throughout the rest of the loop and also moving on the wall.
Right, because the plate underneath that iron does not have perfect specular reflection. If that laser impacted that okay, I'll go ahead and continue. If that laser impacted the bottom of that iron, that plate, you would see it because it's not a perfectly specular surface.
Okay, just claims by you again. Okay, fair enough. But I'm sure Travis will. I'm sure Travis will cover this in his presentation when he comes to present on refraction.
Hold on. Brushed metal is, according to you, a perfectly specular surface then. Because you said it's just a claim, right?
The bottoms of irons that I've seen are polished. They're not brushed. They're quite highly polished to give that flat, even surface in the clothes that they're ironing.
No, mine's brushed.
Oh, okay.
I've seen both.
Well, there we go. Maybe yours are brushed over there, and we have perfectly nice polished ones over here.
Sounds about right.
Well, I'm just about ready to open it up, close it up. Is that all the questions? I mean, I'll take it.
I got one more question. What's more direct order measurement than an elevation comparison of the land you're standing on?
Once more, please.
What's more direct measurement than the elevation comparison of the land you're standing on?
I'm not interested.
Establishing a datum and then going, okay, this land is this much higher than this land.
All right. I understand. I understand your question.
I understand first order measurements without any manipulation.
I understand your question. Okay. Right. I'm not interested in the land. How many times do I have to stipulate this? I don't care what the land's doing. I want a measurement of the surface of the water. You take your datum from the surface of the water and then project your plane out. I don't care what the land's doing. If the water conforms to the surface of your ball and curves at the rate that your ball stipulates it should, or it does according to you, then over the course of 1 mile, you will have an 8-inch deviation in the surface of that water from your datum.
Well, the
End
water
of story.
will be equidistant, right, in elevation, if it's what you're claiming.
Well, so now you're saying
what
that
we see. That's exactly what we see in what I posted. Just
right.
above.
Okay. What is the difference?
Can we address
hang on. Let me just clarify. Let me clarify something. What is your difference between a level line and a horizontal plane? Because at the moment you're describing the same thing in that they follow the curve of your Earth.
Okay. I said equidistant, not level. But
and you were also talking about the land, but carry on.
Equidistant is level over a curved surface. You see, like a tire around a rim. So
you're equating a tire to be level because it's round around the rim. It's got that equal distance from the hub, so that tire must be level. Seriously, is that what you think?
Level to a reference surface, yes.
I'm giving you an example of equidistant curvature.
Yeah, and you also said that is level.
I'm gonna post my visual aid so that you can see what I was referring to. I posted.
You also said that with that equidistant distance makes it level. So you are now saying that that tire is level on the rim.
No, equidistant.
You said that was level. You said that was equivalent to level.
Is another definition for level.
Which equates to the analogy you gave of the tire on the rim. So you are now giving the analogy that that tire on the rim is level.
What I'm saying is, if I put the tire up in the air, and I expanded it past the point of its ability to bend or buckle in any way, you know, past the point you would actually ride on the road with it. I'm telling you that the outer rim to the outside of the tire is going to be it's probably going to be more level than the undulating oceans. That's for sure.
What?
Because it's going to be the same distance from the rims where it's touching the tires, where it's actually holding on to the rim to the top of the tire, because the tire by itself is a circle.
The absurdity,
otherwise
you guys,
it would be a crazy ride if the tire wasn't
lunacy.
equal around.
Yeah, the absurdity.
Hello,
first doofus wants to work harder and not smarter, and now you're talking about pumping a tire past its PSI. What is this?
I'm not saying
it's not
overworking and
riding on the
overinflating.
road is what I said.
Yeah, and it's not a fair representation to say that what I said is we want to work harder. What we do is we go farther so we can measure the thing that we're trying to measure.
Wait, you said we. Wait, you just said we. When have you done this?
Oh, for fuck's sake, dude. Don't address the argument.
Really?
Why don't you go ahead and pull out a single word, and instead of addressing the argument, address that instead.
You know, I did address the argument. You want to work harder and not smarter. I get it.
No, that's not the actual argument. You can misrepresent it every time you want to, though.
But that's what you said, Doofus.
No, it's not what I said. What I said is you go with a farther distance because the thing you're trying to measure gets bigger as you get farther away.
The thing you're trying to measure gets bigger.
You need more distance in order to measure it.
What gets bigger with distance?
The deviation between the verticals at different locations.
Oh, so you have to get further away to measure a bigger deviation, and so you have to get further away from the tool you're looking at.
No, thanks for trying, though. Thanks for trying to troll.
Yeah. Okay, Doofus. I got to give you credit for hanging in there. I mean, Ruhif came in and doxed Rakia and then went off again.
Is it really
that was pointless trolling. You've actually kind of got a method to your trolling, so props to you, Doofus.
Yeah, it's not trolling.
Yeah, it is. Right. Well,
so
if there's no more questions for me, then I'm gonna open it up to a Freeman's because it's getting late here for me now, and I honestly didn't expect this to go for almost 3 hours. So thank you, gentlemen. It's been quite entertaining. There was a lady present earlier. I don't think she stuck around. But so yeah, if you're done with the questions, make it open panel.
I got one question. But just to reiterate, you said lasers are not optical.
And?
I'm just making sure that I have that correct.
Right. A laser line is part of the light spectrum that light is considered to be an optical measuring device. So, I don't know, you odds it, doofus.
It's got a collimator, right? Or some type of, I've got a laser for for my rifle, and it's
Yeah,
got
I
a
mean,
plus and minus, and you can adjust the screws and move the dot around. So I mean, you're aligning something inside the device, right?
Yeah, one would say optically even.
Yeah.
Well, I've got a laser line. It measures the distance of that laser line.
It's going to
Is
be
that optical?
calibrated with
Is that optical just because it uses light? Well, okay, if that's what you think.
Everything that uses light is optical by definition.
Okay, if that's your definition of what is optical, then you go with that.
Okay, what's your definition then?
What if I typed in "are lasers optical instruments"? What if I typed that in?
Go for your life. Go for your life. It uses lasers which are part of the visual or the light spectrum. So, is that an optical measuring device? Do you look at the measurement reading with your eyes? What is the line?
No, I think it's the lasers using lenses.
Okay.
Yeah, here's where it becomes
focus
interesting.
light.
You don't have to look at the light being emitted and measured in order for it to be optical.
Okay. So the laser generates a light, bounces it around between some lenses, and then sends it out of a focal point. And okay.
A laser is a device that emits light through a process of optical amplification.
Okay. Using lenses, it amplifies the light through lenses, which are considered optical devices.
Yeah, the lenses
is the laser light optical? It's one of them questions where we could just get into the semantics of words and argue the toss till 6 o'clock in the morning.
Well, I don't think it would work without the laser, but it wouldn't work without the lenses. So the device to emit the laser has to be optical.
Okay. Well, you're spiraling down into this semantics.
Okay, let's not.
It's not semantic. You're just trying to say that it's not optical, which is not really a valid position.
I'm gonna post my observation 3DP before you go, and I just want you to focus on the second to last image in it. I just posted it in Livestreams.
Yeah. You see, these long distance observations. Travis is your man to talk to there.
Right. I know, but I just want you to focus.
I'm more about the short order measurements.
Yeah, I just want you to focus on the profile, the elevation profile, the red piece, second from the bottom.
The Google Earth, is that Google Earth?
Yeah.
Yeah, and it's a plane.
It's to show you
the elevation profile is a plane. It is a planar elevation profile. Over what distance is that? Over what distance is that?
114
you
miles.
You can't still be getting this wrong, DP.
114 miles of planar elevation profile according to Google Earth. And if you look at every inland body of water in Google Earth, it's in a plane.
Yeah. The elevation profile is plotted against an x-axis, which is flat. The elevations
Cartesian.
the elevations in the y-axis are in reference to the elevations to the reference surface. Those elevations are typically in WGS 84, which is not flat. You've been corrected on this many times, so has Bev.
This is actually the first time I've spoken about this. The reference of the planar nature. But you were talking to me directly, so let me correct your statement, seeing as you corrected mine. Okay, this is the first time I've actually spoken about the planar nature of Google Earth elevation profiles to anybody, let alone you. So you've got a planar Euclidean elevation profile there, and you're claiming what, doofus?
Mike?
The elevations on the y-axis. Yeah, and the elevations on the y-axis are with respect to in this case, WGS 84, which is decidedly not flat.
Right, so
not planar.
you've got two different coordinate systems there that you're putting together. You've got one that's
No.
planar, and the WGS 84, is that a planar reference system?
No.
No, it's not. So you've got a Google Earth planar coordinate system, reference system, whichever, and then you're putting the WGS 84, which is non-Euclidean, on top of that.
With the elevation.
Well, I guess because the elevation.
Who's asking you, people? Who's asking you?
Therefore, the Earth must be flat.
People, who's
I
asking
think
you?
this is an open panel, right? This is an open panel.
No, it's not. No, it's not.
Really?
We can't even hear you. That
Still
your mic
questions
is
for
shit
me.
too.
Yeah, your mic's shit, and I was about to close it up, people. I'm really not interested in anything you have to say because you've been running away from me for over a year. So I'm not interested in anything you have to say, people. Okay? Now, when I open it up, when the questions are done, right, I'm not going to be here because it is getting past midnight and I really need to get some rest. So you can spout your mouth off all you like, people. Nobody cares about what you say. Nobody at all. So sorry, Doofus, back to you. The planar nature of Google Earth elevation profile is quite evident, and then you want to lay another reference system over the top of that to give you the elevation profile. Well,
yeah,
that's what you are claiming Google have done, right? Well, you know,
because they do.
Yeah. Okay. Okay.
Right. All of the elevations
we can
that
go.
are in the
We
elevation
can go.
profile are with respect to WGS 84. That's what they're. That's what they are.
Well, you know, we can go into the minutiae of a Euclidean coordinate system versus a delta coordinate system. We can do that later. Which essentially is what your WGS 84 is a delta coordinate system laid onto a Euclidean reference, and you can't do it, Doofus. It doesn't work. So what you are actually looking at there is a Google elevation profile that's all Euclidean. How about that?
Well, I mean, you can tell me
that's a kick in the balls, that is, isn't it? Why do you need?
You can simply
Why are you talking over? Why are you talking over me? Why are the pair of you
You're not
talking
addressing it,
over
though.
me?
You're not addressing it.
You
You're talking
have
about what I just presented.
You have in that picture you've posted of the Google Earth elevation profile. You have that as a Euclidean image.
I know
and
you don't know
it
the
was
word
measured,
Cartesian.
Doofus, I'm not finished. It was measured using Euclidean geometry surveying techniques. Only Euclidean geometry. You cannot measure curvature standing on the outside of a ball using Euclidean geometry, three-space geometry, and the tools that surveyors need. So your claim that there is a curve which cannot be measured, as I said, from the outside. I've been asking you lot for 3 years now, how do you measure the curvature of your ball standing on the outside of your ball using only Euclidean geometry and surveying tools that work with Euclidean geometry? Not one of you has been able to.
That.
Not
right,
one of you. Measure.
The answer to that.
Measure.
Is,
we're talking measure, Doofus.
The answer to that is basically what your statement is to, if you thought horizontal was not possible on a spherical surface, then you would have a point. But that's a very weird thing to think.
How does that address my question of how do you measure the curvature of the Earth, claimed curvature of the Earth, standing on the outside of your ball using only Euclidean geometry and Euclidean geometry-based measuring equipment?
Okay. I guess I'll have to run through the first steps then. If you establish a horizontal reference, you're establishing that horizontal plane that you love so much. You're going to measure your distance or your differences from that horizontal plane off into the distance. You'll notice then that if you go a certain amount of distance, just keep going, that drop from horizontal happens. That's where you're going to use your Euclidean measurements to confirm curvature exists.
Oh, you got a slope, Jeff. Well, sorry, Doofus. You've just measured a slope. You've just measured a perpendicular drop from a horizontal plane to give you a point lower than your horizontal plane. Now, point to point, you've got a slope. That's not a curve.
In all directions. Okay, if it cannot possibly be a slope if it's downward every direction that you face.
You're measuring the land. You must be on a hill, Doofus. You must be standing on the apex of a hump.
Did you catch that part? We can use mean sea level as a datum.
Yeah.
So?
And that one datum is projected across, well, in the case of the UK, you're looking at 900 miles. From that one datum, they establish every horizontal across the UK. From one datum. Would you credit that? And that is done using straight lines and intersecting straight line segments to then establish further horizontal planes from that datum line. That's incredible. That is all Euclidean.
Okay.
That's a bit of a wow there, isn't it? 900 miles from one datum point. Did you know the datum point in the UK is set down at Newlyn in Cornwall? Right? And this is down in the very southwest corner of the UK. And that one datum is for the whole of the UK, Scotland, and the Scottish Isles. How about that? All set.
I'm failing to see the part.
Wow.
Yeah,
I'm failing to
wow.
see the part
Thanks,
where,
Travis. Travis, that was a wow on point. Thank you.
Yeah, I'm failing to see where the part where curvature was excluded.
I'm failing to see the part where curvature was measured.
Over long distances.
That's your answer. Curvature was measured over long distances. Yeah, nice one.
Yes.
Nice one.
Curvature was measured over long distance.
Yeah. Using Euclidean three-space measuring techniques and the tools that only work with Euclidean geometry. Okay.
Right.
From the outside of your ball.
Horizontal at various locations and not necessarily have them be parallel with one another.
No, well, again, that's a claim of yours that you've never actually done, that you admit you've never actually done, so we can discard that.
Well, if it's a claim and you're aware of the claim, then why are you confused as to how it is we can use Euclidean geometry? Then why are you confused as to how we can use Euclidean? Why are you confused?
I'm not confused.
How we can use Euclidean geometry to measure curvature over long distances.
You can't. You can't use Euclidean geometry to measure curvature over those distances, over the surface of your ball. It can't be done. That's what I'm saying.
Doesn't answer the question.
I'm not confused. It cannot be done. It cannot be measured.
Right. Just saying nuh-uh is not an answer to the question.
And just saying yeah-huh isn't proof.
How on earth can you get through to these people that it cannot be done? You cannot measure.
To you how it can. Can you tell me why that's incorrect?
You get a slope, doofus. All you get every time
like that.
You get a slope.
Right, not in all directions. That doesn't make sense, does it, DP?
If you're standing on a hill, you get the slope in all directions.
Right, that's not a slope. It's not like a plane that's tilted.
You really have no clue, do you, doofus?
He really doesn't.
That's a brilliant response. Thank you.
You're welcome.
It's really productive.
Yeah, you are welcome. You are welcome.
Yep. Right, so it's not a slope if it's downward, no matter which direction you're facing.
Saying it again isn't going to make it true, doofus.
Yeah.
Okay, then why is it that the measurements show drop with horizontal with respect to distance?
Measurements or calculations?
Measurements. The farther
Maybe-
you get away, you observe a deviation from horizontal with anything at the same altitude.
Oh, now you're going into Travis's area of expertise, and I'm really not into this. And Beeble's posting his usual spam shit in the text chat there. So if you're watching on YouTube, Beeble professes to be a surveyor with an auto level, but has never actually been out with the three constituent parts of his auto level, being the tripod, the auto level, and the measuring stick. You actually do need that bit, people. I know you went back and bought it at a later date because you figured you wouldn't need it, but hey, you do you, people. If you want to waste
The rod doesn't change the location of the horizontal reference.
Travis, please walk us through what is happening with those hotels in the background in Beeble's picture, if you would.
Well, first of all, I'm driving, but from recollection,
All right.
yeah, but from recollection, B-ball seems to be in a location that has a pretty uniform climate. So he's going to have a lot of similar effects. The one thing I think you can see very clearly is that there is compression at the lower levels.
Absolutely is.
And then there are certain times I watched all 7 of his videos that he put out, and there was actually one video, I do believe, out of the 7 where he had an inferior mirage. So there was a deviation in the climate at that time. But he and I have gone back and forth over this. I've made my point plenty of times.
Okay.
Oh, look at that one. There's no compression.
So the pictures that no, it's actually slightly magnified. If you look at those, the windows closest to the water there, they are slightly bigger than the windows
That
above.
calls
So
Travis's explanation into question if there's no.
Okay, no, Doofus.
We're not seeing the ground.
Doofus,
It's like halfway up
first
the
of all, I
building.
said I was driving. Okay, yeah, it's okay, boys. First of all, Doofus, I said I was driving. So I was going from memory of other images of the same building that I have seen when it was compressed. So if he chose a photo that had magnification, then that's fine.
in the first pictures he posted, they were actually compression pictures, and then as you said that, Travis, he posted one of magnification. So
Okay.
Where's the compression at?
the ones above.
You have to squint, Doofus. Squint your little eyes.
So that's not the
Okay.
that's not
Can
the
you
water there.
identify it,
That's
though?
something else. Is that your claim, 3DP? That's not the water there.
No, if you want to make a
Where
straw
did I-
man, go somewhere else. Go somewhere else for a straw man, okay?
Yeah.
We're looking at an image that you can't see because you're driving. I'm asking 3DP, why are you trying to
And
say
why are
it's
you
straw
trying to
man
straw
when
man
we're
me?
looking at it?
Why are you trying to straw man me by saying I claimed that's not the water?
I'm not saying, I say, do you deny that that's the water? I'm asking you directly a question, yes or no. Is that
Does
the
it-
water, or is it something else causing the bottom of that building and the rest of the entire city to be missing?
Does it look like a fucking big wave? Yes, it does.
That's a fucking big wave, dude.
Yeah, would you want to get on your board and surf that one, didn't you?
Nah.
We got 50-foot waves, folks.
Again, it's the same exact thing that we see with my observation, except mine's got another 100 miles added to it. And there's
Yeah. Well,
the
what
top
are you
of this
looking at?
island
You're looking at
missing, all the mountain ranges missing, all calculated to be unseen by the Earth curvature. And so all you have to do is take the elevation profile and bend it down at the rate of the curvature.
bend the
scale.
elevation profile.
No. Bend the physical land. Yeah, because it's because that's what we're seeing, and
Yep.
bend it so
All
that
right.
the observer will be seeing the top of the
All right.
mountain, and you've
Do you know
got to
what?
explain. No, you've got to explain where the top half of the South Island of New Zealand went, and 2,000 plus meters of mountain.
Oh, you got it. You got it. You keep going, buddy.
Yeah.
Dude, you don't even do anything beyond 20 miles. Don't talk to me about observations and your Fata Morgana and all this stuff.
Oh,
This
is
is
this?
the clearest-
Oh,
this
hang
is
on,
the
hang on,
cl-
hang on,
no, this is
hang
the
on, guys.
clearest
Wait, I want to hear what I sound like. I want to hear
whoa.
what I sound like. How do I sound?
No, I said I don't want to hear about a Fata Morgana or any of this stuff because there's none of that in the image I showed. There's none of that in the data I provided. There's none of that, but the question of where is 2,000 plus meters of mountain and the top half of New Zealand, South Island, if water is flat and level?
If you haven't figured it out by now, I can't help you.
There's no way to figure it out is the point.
That's a
No, I've got it figured out. I've got it absolutely figured out. You boys have been in this conversation long enough that you have heard these explanations. If you have not figured it out yet, I can't help you.
Right,
All right,
guys.
we've been in these
Doofus,
conversations where
whoa,
people say
whoa,
lasers are not
Doofus,
optical.
Doofus, stop. Right, everybody stop. I'm going to wrap my side of this up now, right? I have done my presentation. I have outlined what I would like us to come together to try and figure out how to do. I've given a couple of demonstrations, ideas. I've put some ideas out there, the laser level across Angkor Wat. Don't know what distance we can use this at. The most sound idea that I find that I've come up with is the 13-meter shots over the canal and extending the plane, and then blitz it with LiDAR. Then we find out what we're looking at, and then you can start arguing the toss. But let's figure out if the water drops from that horizontal plane. Surveyors establish horizontal planes every single day of their working lives, and to say that they can't establish a horizontal plane, Doofus,
Nobody
is just
here
ridiculous.
says that. Nobody here says they can't establish a horizontal
Let me
plane.
finish
Oh,
my
yeah, sure.
roundup.
Go ahead and keep saying they can't, and that's not my position. Strawman me. Do it.
Finished? I'll take your silence as a yes. I just want to surmise, because I'm really tired and I need to get some sleep, basically. So, ideas of how to extend this horizontal plane and measure down to the water. That's all I want. Answers on a postcard, please. Thank you very much for your time, gentlemen. Now, I'm going to unmute you, Beeble, but I'm really not interested in a fucking word you've got to say. You're a spineless little boy, as far as I'm
Good job with your
concerned.
presentation, 3DP.
Thank you.
Well done for being your first screen sharing. I've seen a lot worse than that, from people shifting screens who claimed they knew what they were doing. So you did very good to not have that problem.
Thank you.
Yeah, I mean, I'll take what you said. I actually feel like taking Angkor Wat because of I found the schematics and basic stuff. I like 3D drawing, so I might actually draw it up and just kind of visualize what the elevation profile is saying. But
Lovely.
there's no money in that for me. You know what I mean?
yeah, I know what you mean. But
you
like you, I've just started playing with the printer, 3D printing. But I bought a Delta printer.
The one that prints with the 3 arms and prints up.
Yeah. Well, what it's got like 3 parallelograms, and it adjusts the height of the print head by adjusting the difference in the ratio of the parallelogram arms. So they're of a fixed length, but by adjusting their ratio to one another, it moves the print head around in the print space, and it is absolutely hypnotizing to watch it.
Yeah, when because they do lasers and things, right? They're crazy.
Yeah. Your one, the print bed moves, doesn't it? It pulls the print.
My one, I've got an industrial printer called a CreateBot F430. I actually sell them, and it's got 2 heads on it, and it's got linear rails that move back and forth, and the ceramic glass bed goes down. It moves down away from the print.
Yeah. See, mine's the opposite. The bed is fixed, and the print head is moved around in the print space by the parallelograms.
What's the print bed size?
It's actually round. It's the only one with a round print bed, but you can do prints that are about a foot across. So, but the print volume is up to, I think it was 268 millimeters high, which is quite a height for the 3D printers. But
yeah,
the reason
my
I
first powder printer was like a little 10 centimeter square box, and it was for the like silhouette 3D. Basically like $200, like 200-pound, entry level thing, just to see if I wanted to get into it.
Yeah, well, I didn't pay much more than that for this one.
Yeah, I quickly realized I'd bought a gimmick, so then I went and bought a Ender
proper
3
one.
secondhand.
You went for the Ender, yeah?
I went for the Ender 3 secondhand, because I figured I didn't even know if I want to get into this, because I started with DLP printing,
Right.
resin printing,
Mhm.
and yeah, I was like, I don't know, people, reading forums about it and everything, so I just went and found this secondhand one, picked up for about 150 pounds, came with a table and Raspberry Pi,
Right.
camera and everything. And I basically maximized that out until I couldn't print the clearances that I needed within the gears that were moving, and so that's when I went back and got the one I've got now. So yeah.
Yeah, I'm really glad that I chose the Delta printer over the Cartesian one, because you look at geometry in a different way with that, because it is using a completely different coordinate system, and it allows you to see the difference between the Delta coordinate system and the Cartesian coordinate system. And how do you model a sphere? You can't do it Cartesian. You have to do it Delta. So, because Cartesian only gives you circle by circle by circle, but the Delta coordinate system gives you a sphere in a print area. It's printed as a Euclidean plane, but the actual coordinates in the machine is the Delta coordinate system. And
yeah, maybe you could do another presentation on that 3D printer one day as well. You did a really great job today, and it was really interesting. And is there somewhere to maybe get together with this information? Yeah, send you some links or.
Is there any way we can? Sorry, say that again, Tanks.
So if somebody has somewhere they want to add, you're just looking for answers. You're not saying you have the answers, right? You're looking for a project, right?
Yeah, well, I'm looking for input from people around the subject that I've put forward tonight. So, I mean, there's the Discord server, which is this flat Earth, that flat Earth. Sorry, the YouTube is this flat Earth. So it's that flat Earth in Discord. This flat Earth on the YouTube channel. And yes, if you got any input for us, just hop onto Discord and jump into the server. It's an open server. Nobody has any roles in that server. We've kind of decided to put it forward as an open server where everybody is equal. And what we're trying to do is get people to respect the server and respect each other person that is in that server, and treat them as people, not as internet trolls, or we do get the trolls in there, and the trolls do become self-evident, but we're trying to have a genuine, open, honest conversation and trying to sort out, because at the end of the day, we're all people. We've all got different opinions. Me and you, Doofus, we got different opinions, but we're just people. You think you have the answers, and I can see flaws in your answers. Now, would you rather have questions that can't be answered, or answers that can't be questioned?
Right. You say that you see flaws in the answers, and it's fine that you just say that. But when we say it's possible, not just that it's been measured, but that it's at least possible that horizontals at different locations are not parallel with one another, you need to acknowledge that your test does not differentiate that, does not test for that.
But then you're saying that the surveyors can't do their job, Doofus, because surveyors construct horizontal planes over distance. and that horizontal plane is level. Now,
what surveyors
now-
do is they establish a horizontal and a local area and use differential leveling to carry that elevation.
Right,
That
okay.
means that means the stated purpose of differential leveling is to remove the effect of curvature. That's what they're trying to do.
Right, so if that's the case, you're removing the effects of curvature using differential leveling. So if you differential, oh God, I'm tired now. So you do that differential leveling over the course of 1 mile, then you should be able to measure the drop of the water.
No, not with differential leveling. Its
But
entire purpose
you said
is to eliminate the cause of the deviation, which would be curvature.
Right, which is your level line. So now you're saying that horizontal is conforming to the level line.
No. Horizontal is only taken over a short distance. And during differential leveling, and the level line that is then established, that is not your horizontal reference.
Can a surveyor establish a horizontal reference over the course of a mile? Which was the question I initially asked you, and you said yes. And then you went off into differential leveling, which then became your level line. I'm asking for the horizontal plane, doofus, not the level line. Can that horizontal plane be established and then projected over the course of 1 mile using surveying techniques?
Then projected how?
However surveyors project a horizontal plane.
Okay. They typically don't. They project an elevation.
I'm not asking what they typically do and don't do. Can it be done was the question, doofus.
Right. If you want to establish a horizontal plane over a long distance, you can just use one horizontal reference and use the long distance. If you want to establish a horizontal plane over shorter distance runs along the path, if you want to establish a horizontal plane along shorter distance, if you want to establish
Which bit of this don't you understand,
doofus? If you want to establish a horizontal plane over a longer run using shorter... Oh, for fuck's sake. If you want to establish a horizontal plane over a longer distance using shorter runs along that distance, then you have to use the curvature. You have to exclude that, and you have to put those deviations into those runs that you're making.
Right. And this curvature will be the curvature that's never been measured and only assumed, cannot be measured using Euclidean surveying techniques. Well, it can't be measured, doofus. You're trying to measure a curve
how you can.
from the outside of a ball using only Euclidean geometry and Euclidean surveying techniques. All the best you get, at best, you get a slope angle. And that's not a curve, doofus. And I'm finished now. So it's open. Beeble's mic's been open for about 20 minutes now. So I'm done, Geo. Thank you very much for your space, your consideration, and your time. That's it. I'm out.
Thanks, really big.
Yeah, I explained how you can. You're just saying that I didn't explain it though.
Okay. Okay, doofus.
I mean, you didn't have a response to the method that I stated. You just said, nuh-uh.
No, doofus, you cannot
agree to disagree, I think.
Yeah, exactly. We will agree to disagree, and I'm wrapping it up, so I'm out of here. So I shall catch you later. Beeble, when you grow a pair and you man up for that debate that you challenged me to over a year ago, just let me know.
What are you gonna
show? What?
What are you gonna show if we have this debate? What exactly are you gonna present?
What was that, Beeble? Speak clearly into your
what
microphone.
exactly? Hold on, 1 second. Let me change something. What exactly are you gonna present if we have a debate? Can you hear me now?
Beeble, you challenged me to a debate, and you went round all the servers I couldn't get into, telling everybody that you challenged me to a debate, and then you ran away when I accepted your debate challenge. What the fuck makes you think I want to waste any more time on a twat like you?
Told you I
People,
couldn't.
you are insignificant.
Can you answer the question?
You
What was my
mean
response
nothing,
to-
people.
Because guess what? There will be a time when we'll have this debate. But what was my
talking.
response when I told you I couldn't debate? Can you remember?
What was your response when you told me
When
you
I told
couldn't?
you that I couldn't
Let me
debate.
finish, people. Are you
Go
going to
ahead.
talk straight through me?
Go ahead.
What was my response when you told me you couldn't debate? I said, you're fucking right there. You can't debate, mate. You can't stop fucking talking.
No. I said, what was my response when I told you why I couldn't do it?
Because you're an imbecile.
No. Is that what we're gonna do? We're gonna add harm?
No, I'm just telling
Is
you
that
what
we're
I
doing on
probably
this?
said to you,
So
people.
what I said was at the time when I had challenged you to that debate, I had actual time to do it. I had time to sit down on my computer for an hour, 2 hours, whatever. And then that changed. When
No,
I
that changed and
didn't have
people
the
couldn't sit down
debate.
at his computer, but he can get really shit phone
So
signal just like
I
now and
don't
spout
sit
his
around.
shit all over the place.
Go ahead, I'll let
Yeah,
you when you're done.
I'm done.
Okay. So I have like a career, you know what I mean? I jump
You
on
call
when I
it a
can.
career?
When I can.
I'll say you
When I
cannon
can, I'm
fodder.
not okay, you're just gonna talk through me now that we're doing? Okay. So I don't have time to sit around on my computer all day and create memes and post them. Okay. I have a life, I have a family, I have a career. So I don't have time to sit on YouTube and have a debate for 1 or 2 hours. Once in a while I might, but that time is few and far between. Okay? But guess what? There will be a time in the future when I go to Korea when you and I will have this discussion, okay? And I will let you know when we can have that discussion, okay?
You'll let me know. You think I dance to your tune, people? You are insignificant. You're an insignificant little troll, people.
You'd like
You
to have
think
this debate, though, right?
you think you think I'm hanging on, waiting for a debate with you,
Would you like to
people?
have this debate?
This is
Yes,
incredible.
yes or no question. Would you
This is
like to have
incredible,
this debate?
people. You've been running away from this debate for over
Well,
a
I just told you
year.
why I couldn't do
So
it.
no, you've
I
made
just told you why.
excuses.
Guess what?
That's all you've
It doesn't
done.
happen.
You've made excuses.
It
I
doesn't
have a
happen.
career as well, people.
Okay, good.
I have a life.
That's great. So listen.
Let me finish my sentence. I gave you the
we're gonna-
courtesy of getting through your monologue. Please do me the courtesy of letting me get through mine.
If
I
you're
too
not
have a
You spoke through him the whole time. What are you
I too
talking
have a
about?
life. I did
if
at
you're
the
just gonna
beginning.
Man,
Oh, come on, you two.
3DP, I thought you were different, man.
No, I did speak through him at the beginning, but then I backed off and I let him finish. You got to give me that much.
All he can do to me
Phoenix.
is this instant. That's all he can really do.
Phoenix, you got to give me that much. I spoke through him at the beginning, and then I let him finish.
Yeah, but DP, go to bed, man.
Yeah, you're just not worth me wasting my time on people.
Right.
You're insignificant. So
Right.
I'm going to bed. Thanks, everybody. Catch you all later.
Thanks, DP.
Yeah. See ya.
Right. So he
Brick is in the house. B Brick. What's up, B Brick?
Travis, I
Travis.
snapped at you before, but you were also speaking condescendingly about us in the room. So it was like 3 strikes, and then I went you. So that's what that was about.
I don't even remember, man.
Good.
So I mean, he invites me to his presentation. Then he has a picture. Okay.
It is a bit weird, though, right? You get an invite to come along just to listen, and when you try to speak, you get attacked.
Yeah, pretty much.
I mean, that's what a presentation is, right?
Well, everyone else got to chime in, and I was chiming in. So, but he has a personal thing against me.
Yeah, it was an open, because I wasn't talking during the whole presentation either. I was learning about it, you know. But I think, you know, I think that the elevation of that water, if it was truly planar at sea level, then it would be like, what is this place, you know? But the fact that it's 55 meters above sea level, I mean, have you ever swum in a 55-meter pool?
We double check that optical assessment.
Hey,
Well, that's the
Bebop.
thing. I mean, it's a cursory search, you know, like just like elevation data for this area, or click this, click here, you know, and just get a basic area. But 3 different sites, 4 different sites, all said around the same elevation. So
Are we
Bebop,
about
what
to
do you?
get into the realm of optics are unknowable?
Let me ask
Hold
Bebop a
on.
question real quick.
Go ahead, baby. Go ahead, Brian. See, Brian, I like. See, look here, Brian. I like Brian. I know me and Brian don't get. Sometimes we kind of, but I like you, Brian. I do. Go ahead, man.
Yeah, you're
Very
all right,
nice.
man.
Very nice,
For
polite way to enter,
for a
Brian.
man
Thank you.
full of shit, dude, I kind of like you too, man. But no, I understand we have different worldviews, man. So you know that's just you know. So I go into the talk acknowledging that, so I don't hold that against anybody, man. I hope they don't hold it against me. But I was just looking at the like the distances and everything because we had the talk yesterday, and I was like thinking about the distances, and so I checked. What do you think the distance is? Because I was thinking across the United States, I'll just round it off for a couple thousand miles, and then I went ahead and did the math. What do you think the difference in distance is? Straight line distance and curve distance for 3959 radius over 2,000 miles. What do you think the difference in distance is?
You mean like the
maybe like 1,500 miles, something like that.
You talking about like the difference between a
23
curved line
miles,
and a
dude.
straight line?
That's the difference in distance is only 23 miles. So
You're
when
talking
you
about
start,
I'm sorry.
yeah, well, if you could go to the triangle calculator and put in radius 3959 for 2 legs of the triangle,
Yeah.
and in 30 degrees, and you get a straight line distance of 2,049 miles, and then you could take the circumference, you know, just multiply the radius times 2, and then multiply that times pi, and divide that by 12, which is 30 degrees also, and you get I think 2,000.